Swinburne University of Technology.
Hi and welcome to Swinburne Codecasts. I'm Andrew Kane.
And I'm Jake, and in this video we'll be taking a look at compiling our own programs.
When we create our own programs, what we do is we type code in using a certain programming language. We call this source code. But the source code isn't something the computer can run directly. So what we need to do is convert our source code into machine code using a tool called a compiler.
Yeah, and to run this compiler, we need to use something called the terminal. So let's just have a quick look at our Hello World program we've written.
So here's Hello World. This is written in a programming language, in this case, the Pascal programming language. And it lists out the instructions for the computer to execute. In this case, it's just going to print a message out to the terminal.
Yeah, so we need to use the terminal to run the compiler. So let's have a quick look at the terminal. And there's really not much going on. So do you want to just have a quick explanation of the terminal?
So the terminal allows us to run commands via a command line interface. So we can enter text, and that text is a command, tells the computer what we want to do.
Yeah, so the very first thing we need to do is move to the location of the source file.
Yeah, so the terminal runs in a directory. It has a working directory, and the working directory, we want to make that match our source code directory.
So currently
so we can change into that directory using cd. So the cd command allows you to change directory, and it's in your users document, your user directory, sorry. So users Jake in this case, and documents. And that matches up with the terminal. With the
Finder.
Yeah, that matches up with Finder. And so what we can do is we can actually list the files in this directory using the ls command.
So just like you'd see in the Finder, all the files and folders in the window.
So in Explorer, in Windows, or Finder in Mac.
You can see them in the terminal right here.
Yeah, and we can see that the Hello World file is there.
So how do we convert this to machine code?
So we can run the compiler. So the compiler for Pascal is going to be the free Pascal compiler.
Cool.
So the free Pascal compiler, FPC, free Pascal compiler. And we give it one option. And the one option we need to give it is -S2.
Cool.
So that tells the compiler that we want to use a more advanced version of the syntax. The free Pascal compiler can actually compile a number of different Pascal dialects. This is the one that we want.
Yep. And what else do we need to give it?
We also need to give it the name of the file that we want to compile.
Because it needs to know to convert this file.
That's correct. Because we could have had lots of Pascal files. It needs to know which one.
So when we run this command, it will compile our Hello World program.
Yeah. So if we do an ls now, or we look in Finder or Explorer on Windows, we should see a program there, the Hello World executable.
Yep. So that has been generated from our Hello World source code when we ran the compiler.
Yeah, and we can run that now. You need to put // on Unix. Windows doesn't matter quite so much. Dot means the current directory. So // means in the current directory, run the Hello World program.
Yeah, exactly.
When we run that,
see Hello World, it's worked.
Awesome.
Cool. So what else do we need to do with the terminal?
Okay, so one other thing that we need to have a look at in the terminal is the way that we can compile Swingame programs. So Swingame is a library that we're going to be using to help you learn how to program. And
it has a more involved compilation step. So there's a script written that we need to run, and that will do the compilation for you. Yeah,
so it uses a build script. So if we move into, I've got a directory here. One thing we can do when we're moving into a directory, I want to move into the Swingame starter directory inside your documents folder.
So you don't need to write the entire directory or path to get there. It knows, look for Swingame starter file in the folder that you're already in.
Yeah, that's right. Cool. So here it will now jump into the Swingame starter folder.
Yeah.
And if we do an ls, we can see the files that match those that are in the actual directory.
Yeah, and while you don't see a Pascal file here, you do see the build script, and that will know to run any Pascal file in the source folder.
Yeah, so we can run the build script the same as we ran the executable file before. So we say // in the current directory, run the build script.
Yeah, and when we execute this command, Swingame will build the Pascal file inside the source folder.
Yeah.
And if there was more than one, it would give you the option to select which one.
Yeah, that's correct. You can then run it by using // run.sh.
Yep.
And that will actually run the program, and the window will pop up or whatever you want it to do.
Cool.
One thing to note that makes this much easier to work with is tab for auto-completing.
Yep.
So when I was moving into the users folder, you can do US for users, press tab. If it isn't unique, so in this case I need to put in a few more characters. Users. Yep. But if we do Jake, JA,
Yeah.
and we press tab, it will autocomplete. Documents, DOC, tab, it
Yeah.
autocompletes.
Cool.
So tab is really very useful. The one other thing that's useful to know is the up key to cycle through previous commands.
Yeah.
So you'll find you'll often build and run.
Yeah.
Build, run,
And you
build,
can
run,
just
build,
switch
run.
between them.
Just switch between the two.
So that's been a really quick look at the terminal. There's a lot of other powerful functions that it performs for us, but
Yep.
they're the basics to get you building and compiling your own programs.
Hope you enjoy this, and we look forward to seeing you again soon.
Bye.
Bye.
This has been a Swinburne production. Swinburne University of Technology.
Hi, and welcome to Swinburne Codecasts. I'm Andrew Kane.
And I'm Ruben, and in this video we're going to be looking at syntax.
We've been teaching programming for a while, and one of the key things I think when you start to learn to program is to understand the idea that programming is much more about concepts, so programming concepts, than it is about programming language.
Yeah, and that sounds really powerful because, once I learn these concepts, I can apply them to any language. So rather than just being stuck with one language, having an understanding of these concepts will allow me to adapt that to many languages.
Yeah, that's right.
So what I really need is, I'm not at that level yet, so what I need the tools to be able to convert my concepts into code.
Well, what we need for that is a way of understanding the rules of the programming languages. So each programming language has its own set of rules for how its code needs to be typed into the computer. And that pretty much tells you if you want to create this thing in your code, so you want to create, say, a program in your code, you type this. If you want to create this other thing, like a function or a procedure, which we'll talk about later, you type this. So what we've got in order to help with this is there's a book that we've created called The Programming Arcana, because we think programming's pretty magical.
Yeah.
And the Programming Arcana includes in it syntax diagrams for a number of different programming languages. And so you can use this to pick up sort of any of those languages. All right, so in order to create a program, what we need to look up in the syntax rules, so in the Programming Arcana, is the syntax for what? It's the syntax for a...
program.
Yeah, tough, hey?
Yeah.
All right, so here's the syntax. We'll start with a Pascal program. So we'll
Yeah.
write it in the Pascal language.
Yeah.
So here is the syntax diagram related to the rules for Pascal in order to create a program. And it's called a railroad diagram. So you follow along the arrows. You start at the start and you go to the end.
Makes sense.
Yep. And along the railroad, you'll encounter different symbols.
Yeah.
Yep. These rounded rectangles, which are grey, have things that we type directly in the code.
Yep.
So for our Pascal program, what are we going to type first?
Program, I gather.
Yes.
Yeah.
Yep. This is the good thing about Pascal. You want to create a program, so you type program.
Yeah.
Yeah. It's not very cryptic, which is nice. All right. So that grey box just means that. So in our code at the moment, what we have is just the word program.
Yeah.
And
Yep.
so we've got past that point, and you separate it by white spaces. So tabs, new lines, spaces. So
Yeah.
I think at this point we put a space before the next thing. And so the next thing is,
We've got an identifier.
all right, now that's in a different colored,
Yeah, it's red or pink. I
Yeah.
don't know what you call that, but
yeah, I don't know either, pinky.
yeah.
Yeah, anyway, the pinky colored rectangle is actually another rule. All right, so this is another thing, a term. So in programming, an identifier is the name of something.
Yeah.
And there is a special rule in Pascal, as in other programming languages, for what an identifier looks like. And so we need to find the identifier syntax And it tells us an identifier looks like this.
Okay. So it's got to have, well, it's got to start with a letter.
Okay, well, we've actually got two options here. Notice that if you follow that railroad from the very start, you've got that fork. You could go one way or the other.
All right.
So it could start with a letter or an underscore. That was very difficult. That is actually an underscore. It's not a minus.
Okay.
It's the underscore, all right?
Sure.
It's hard to tell the difference in this, but that's what it is.
Yep.
So you got, so it's a letter or an underscore.
Yep.
All right, now we've got two different symbols here. So one of them's the square and one of them's the round one. Which one would I type directly in and which one is a different rule?
The round one
Yeah, so the underscore
is what you would type in. And the letter, that's a separate rule? What do you mean?
Yeah, that's right. Yeah, that's exactly it.
Okay.
So letter is a separate rule. Underscore I type in. So if I want the name of my program to start with an underscore, then I can put an underscore.
Yeah.
What do we want to call this program?
Test program.
Yep. Okay. So test program. That means we're going to type a letter.
Yeah.
Yep. So we can go to letter, and a letter is another rule. This is how pedantic computers are. All right. Computers are unintelligent. They have no brains.
Okay.
They just follow instructions, and so it needs to be incredibly detailed.
Yeah.
And so the syntax for a language is right down to every single character that you type in.
Mm-hmm.
So a letter is literally a letter. It's A, B, C, D, etc.
Yeah.
Yep. So we're going to start it with T for a test program.
Yep.
Yeah. Once we follow the syntax, well, when we finished our letter, that gets to the end of the letter.
Yep.
We can now go back. We continue along the syntax diagram. And so we could call the program just the letter T.
Yeah.
Or we could call it just underscore.
It's not very meaningful.
Yeah, that's right.
Yeah.
So we can call it test. If we follow this down, we can go through letter again.
Yeah.
We can pick up T, E, S, T,
Yeah.
P, R, O, G, R, A, N, etc.
Yeah.
And so the identifier can be test program. Now, in the future, the idea would be you only need to look these up sort of the first few times you encounter it until you can work out what the sort of overall rule is.
Yeah.
So we can see here the rule for this is effectively it's got to start with a letter or an underscore, and then it can have letters, digits, and underscores inside it.
Yep.
So we could have test program, but we couldn't have test space program.
But you could have test underscore program?
Yeah, that's right. You could have test underscore program. We could have test 23 program.
Okay, yeah.
But I couldn't have 23 program. Yeah.
Yeah.
Because it can't start with a number.
No, yeah.
Yeah. Okay, so that's now our valid identifier. So at the moment, what we will have in our code is program followed by test program.
Yeah.
And so we now go back to the program syntax. So we finished our identifier. What comes next?
That looks like a semicolon.
Yep. And notice it's in the grey. It's in a grey rounded rectangle.
Yeah.
So that means, what do I do with this?
Well, it has to have that.
Yeah, we just type it directly
Yeah,
in. I don't need to look up what a semicolon is. It just means
Yeah.
semicolon.
Okay.
Yep. And what could come next?
We could, looks like, what, a user's clause? A block, rather, actually.
Yeah, no. So it could be a user's clause or a block, couldn't
Yeah.
it? Because we've got an option here. We can put a user's clause in. And so if I did, it would look something like that.
Oh, yeah, yeah.
Yeah. And that's because a user's clause has users followed by the name of the user unit identifier, which is an identifier. And then I could have a number of those separated by commas.
Yep.
And then a semicolon. And so this says this, at the moment, this program uses SwinGame, which is a library that we're providing that has sort of functions for audio, video, networking, a whole bunch of things. But if we don't want that, then we don't need that users clause.
Yeah.
And so after the users clause, whether we have it or not, the next thing is going to be our block.
Yeah.
And so we can find that rule just down here.
Yep.
And so block starts with,
Begin.
yep. So I just type begin in, don't I?
You do?
Yep. Yeah.
Cool.
And we could, seeing as we're doing the begin, we could probably also put the end, because each block is a begin end with a number of statements in between.
Yeah.
So we have begin, we have some statements, and each statement is a command that tells the computer what to do.
Yep.
And we then have an end at the end of that. And so we can put our begin end. And after our block, we end up with we'll come back and put the statements in later.
Yeah.
At the end of the block, we have a full stop.
Okay.
And so that's sort of the skeleton of our program's code.
Yep.
So in Pascal, that's what we type in order to create a program. The statements then, we could have a look at, well, what is a statement? A statement, at the moment, we have the option of a statement being a procedure call. And when we execute, that's another rule.
Yeah.
When we execute a procedure call, we need to put the name of the procedure.
Yep.
And then we can have some brackets with arguments, which are values that we provide to those procedures. And so here we've got WriteLine, which is a procedure in Pascal that prints things out to the terminal. And inside the brackets, we can put values that we want to print out. So this is printing out hello world. But expressions, which are values that we use inside our program, you can calculate them in, there's many different types of expressions. So you can have things that are numbers, like 73, or, if you want real numbers, you could use something like 2.1.
Yeah. Or strings even.
Yep. So like hello world or Fred.
Multiplication, addition, division.
Yeah. So any of these things which are the sort of mathematical expressions, so that they calculate values or they are a value, can be placed in any of those points where you've got an expression.
Yeah.
All right. And so we could call, in our program, we could call the WriteLine procedure, or maybe we could call that twice.
Yeah.
And so this should be valid syntax, because what we have at each point is we've followed the rules.
Yeah.
If we compile that now, when we run the compiler, you can see that we get some output to say that it's compiled successfully.
Yep.
The program is completed successfully.
Yeah.
Now, if we make some mistakes, like imagine I don't have the end.
Yeah.
And we then save that. If I recompile it, you'll get a compiler error.
Okay, is that because the compiler's looking for an end?
In this case, yeah.
Yeah.
So the errors can be cryptic sometimes, but in each case it tries its best to tell you where it went wrong. But remember, it's it's more than stupid.
Yeah.
It's unintelligent. So it will do the best it can to sort of try to output some meaningful message, but it can be quite cryptic. And that's why it's really good to understand some of these basic programming terms.
Yeah.
And I think the really, really key ones are identifier, which is the name of something in your program.
Yeah.
A statement, which is
something that the compiler executes?
Yeah, that's right. So it's an instruction.
Okay.
This is a command. This is what I want done. Do this now. Expression is the other really key one, which is a value, something that we calculate. So often the error will say something like, this statement was expected.
Yeah.
So that's something about a command. Or invalid expression.
Okay.
It means that calculation doesn't make sense.
Yeah.
You've got something in there that doesn't compute. Yeah. Or identifier not found.
Which means that doesn't exist.
Yeah, can't find that name.
Okay.
You've got a name there. You've either spelt it wrong. You've got something's wrong with the actual name.
Yeah.
Inside that identifier.
Yeah.
So those parts of the syntax are really important to understand.
Cool. So I can definitely see how we've applied those concepts to one language. What about applying them to another language?
All right, well, let's have a look at a C program. So this is the code for a C program.
Okay.
And what we can do is we can have a look at the syntax rules that we use and this in fact is exactly the same program.
Yeah, well, it looks very similar, bar a few differences.
Yeah, so if we look at the syntax rules for C, we can see that in C, a program optionally has some header includes.
Yeah.
And this gives you access to libraries.
Okay.
Now, Pascal actually gave you some libraries for free.
Yeah.
C doesn't give you anything for free. So you need to tell it everything that you want.
Yeah.
And the one to print things out is the standard IO library.
Yep.
So we have to hash include that. So that's our header include. That says give me access to that library. And we can see that's just followed those rules there.
Yeah.
In order to do that. Once we've got that, we then have a main function. This is where C programs enter, just like the begin in a Pascal program. And so we just type the code in here.
Yeah.
And we have a block.
That's exactly the same as a Pascal program.
Yeah, that's right. That's very similar, isn't it? But a block, instead of typing begin, we have a curly...
Braces,
a brace. Instead of end, you have a close brace.
Yeah,
It's so massively different. Nobody would ever, be able to pick that up on their own. Sorry. Being very sarcastic here.
Yeah.
Yeah. And we have statements. So notice that C still uses the idea of statements. It still has the idea of identifiers. If we look, say, at a C procedure call, you've got the name of the procedure, which is an identifier. You have brackets, which is like the same as Pascal, and then you've got arguments. this terminology is pretty much the same across programming languages.
Yeah.
So all that's different is some small things like braces instead of begin and end. The bigger thing, though, I think that's different are like printf.
Yeah.
So the different features or different things the libraries provide you do change, and that takes a little bit of time to pick up, but the core of the language is the same.
Okay, so basically I can do the same thing in many different languages. It's just getting used to the visual differences in syntax.
Yes, that's it. Yeah, so that's why it's really important to focus on understanding the concepts first. Don't stress too much about the syntax. Pick an easy language that's nice to work with, like Pascal. Work through that one. And then when you finish that, you've got the idea. It won't take terribly long.
Yeah.
It will only take a couple of weeks. You can then pick up other languages really quickly, build upon that really solid foundation of understanding the concepts.
Yeah.
All right, that's it for the basic overview of syntax. What you probably want to have a look at next, so what are some of the other videos we've got?
Yeah, so we've got some videos on the compiler, installation videos to help you get everything that you need set up and going, writing programs, and if you're ahead of all of that, why don't you check out the video on variables?
Yeah, cool. All right, and that's all we have time for this video on syntax. I hope you've enjoyed it, and we'll look forward to seeing you again soon.
Bye.
This has been a Swinburne production. Swinburne University of Technology.
Hi, and welcome to Swinburne Codecasts. I'm Andrew Kane.
I'm Jake.
I'm Ruben.
And I'm Cliff.
And in this series, we're going to look at the concepts related to procedural programming.
Each video covers one concept in depth and demonstrates to you how you can achieve certain tasks with a programming language.
And when we step through the code, we'll be visualizing the computer's memory, and that's something we call hand execution.
We'll also be providing you with an output window to show exactly what the program's going to be doing, whether it outputs to the terminal or whether we've got a graphical interface to do that.
Okay, we hope you enjoy this series, and we'll look forward to seeing you soon.
Bye.
Bye.
That's pretty good.
This has been a Swinburne production. Swinburne University of Technology.
Hi, and welcome to this podcast on the installation of the tools we're going to need for programming in Linux, the Introduction to Programming unit. So, what do we need to install? Well, with Linux, it's not too much, so it won't be too onerous to do this. Other operating systems, not so easy, but this should be pretty simple. What we're going to install is the Synaptic Package Manager. We're going to use that to install the free Pascal compiler. We're going to use a deb file to install Sublime Text 3, along with package control inside Sublime Text and export to HTML. And then I'll show you how to use these tools to create a Hello World program. With this, we are using Ubuntu as the Linux distribution. If you're using something else, then hopefully this will be beneficial anyway. All right, to start off with, the Synaptic Package Manager. So we can use the Ubuntu Software Center to install this. If you just open that and search for Synaptic, choose Install, wait a few seconds, and we have the Synaptic Package Manager. We could install this from the command line, but I thought I'd show you how to install it with the graphical tool. we'll have a look at installing things from the command line in a future podcast. All right, now the Free Pascal compiler. So we're going to be using Pascal at the start of the unit. We need the Free Pascal compiler. So open up the Synaptic Package Manager. You'll have to authenticate. Search for FPC. So FPC being the Free Pascal compiler. When you find that, select it and mark it for installation. And then click Apply to install it. And this will install the Free Pascal compiler along with the various tools that it needs in order to compile your programs. So that'll take a little bit. When that's finished, we can move on. All right, next is the Sublime text editor. So this is a graphical text editor. It comes with a lot of plugins. Makes it really good for editing code. There's a Debian file, a deb file you can use. So just double click that. It'll open up in the Ubuntu Software Center. Choose install. And in a few minutes, you'll have Sublime text installed. So we're getting pretty close. Okay, now to install package control. Open your web browser and search for Sublime Text Package Control. When you get the Google page that lists that, it should show you the installation page directly. Go straight to that page, save a bit of time. And what we can do is if you scroll down, you can see that it gives you some code that you need to run in order to install package control. So it's actually really simple. If you just copy that text, just select it all, right click and copy, or Control C, Command C, etc. to copy, then switch back to Sublime Text. And from View, show the console. And this is where we can type some commands directly. So if we paste that command into that little text box down the bottom there, press Enter, then it will install package control. So it's not too hard. You've just got to wait a little bit. Once it seems to have installed correctly, this one doesn't show you much progress, but it'll take maybe a minute or two to install. Once it's done, you've got package control installed. So hide the console, and we can now use package control to install another package. So package control is a utility that lets us install what are called packages inside Sublime Text. And these packages add extra features to the text editor. And the one that we need is the feature that allows us to export our code to HTML. One thing that Sublime Text doesn't have is the ability to print things directly. So what we're going to do is export our code to HTML and then use your web browser to print it to a PDF file, which you can then submit as part of your weekly assessment for the unit. All right, so inside Sublime Text, to run the different commands inside Sublime Text, what we do is hold down 3 keys. On Linux, you need to hold down Control-Shift-P. With those keys held down, it'll pop up a little box into which you can type the command that you want to execute. So we're going to use package control's install package command. We could type any part of that. Probably the easiest bit is to type install. So type install, and you should see the option package control install package. Select that and press enter. That will run that command. This brings up another menu once it's updated the packages, and that menu allows you to select which package you want to install. So you can have a look through there. There's heaps of stuff that you can install. Sublime Text is a really great text editor to use. In this case, we want the export HTML package. So type export, and you should be able to see export HTML. Select that, press enter, and it will go ahead and install the export HTML package. You can see the progress this time down the bottom left. So that's nice. You'll see that install. We're all done. We'll show you how to use this in a minute when we do a walkthrough of the language and the tools. All right. Now we can use all of this stuff we've installed to create a program. So open Sublime Text, and we can create a new file, and we'll save it as hello world.pas. PAS stands for Pascal, and that will tell Sublime Text that this is Pascal code, and it will syntax highlight that with that language, with the rules for that language. One thing to make sure you do is don't put a space. So it's not hello space world, it's hello world, one word, .pas. That's all just one word. The terminal and lots of programs you run from the terminal are difficult to work with if there are spaces in file names or spaces in path names. So avoid spaces pretty much for all file names. All right, I'm going to save mine into the desktop, but you might want to save yours into a documents, my documents folder or something like that. All right, we can now type in our program's code. And as you do this, you should see the text editor highlighting different parts of the text in different colors. This is because it understands the Pascal programming language and can therefore use that to give you some feedback on how you're going. So this program is program hello world, semicolon. We then have begin. I usually put the end in straight away. The end matches the begin. So we start at the begin, we end at the end, put a full stop at the end, and we will run one instruction, which is to call the write line procedure. So we type write line, write ln, no spaces, notice, open brackets, and then in single quotes, we'll put the text hello world, exclamation mark, close bracket, semicolon. So that tells, well, that's our instructions to the compiler for what we want the program to do when it creates it. All right, now we've got our code. Save that file. Use Control S or Command S on Mac. Alternatively from the file menu, but get used to the shortcut keys. It'll save you time. All right, now that the file's saved, we need to compile the program. So you need to do this from the terminal. So open the terminal. On Windows, use MSys or the MinGW terminal. And we need to CD to the location where you've saved the files. So I'm going to CD to my desktop. On Linux or Mac OS, it would just be CD space /users /acane /desktop. And I can just usually shortcut that on Linux and on Mac just by using CD desktop, as I'll start in the users acane directory. All right, now let's use the compiler to compile our program. Run fpc space -s2. That's an uppercase S, not a lowercase one. Uppercase S2. And hello world.pas. That tells the compiler to run, or to run itself. So we're running the compiler. The -S2 gives it options to tell it how we want it to compile the file. And S2 stands for a more advanced version of the syntax. So syntax 2, not the basic syntax, but the more advanced syntax. And hello world.pas is the file that we're going to compile. So it's going to compile the hello world.pas file and create a program for us. So when that runs, you can see we've got a hello world executable created on my desktop. So we can run that from the terminal /hello world and press enter. You could double click the file as well, but the terminal window will probably close straight away, so you won't actually see what it's done. So it's easier to run it in this terminal. Okay, so that's creating a program, compiling it. The other thing that you'll need to do as part of the subject or part of a unit will be to submit code. And when we submit the code, what we're going to want is a PDF version of the code so that we can annotate it to give you feedback, etc. So go back to Sublime Text and press Control-Shift-P on Windows and Linux, or Command-Shift-P on Mac OS. And this will bring up that menu of commands that we can tell Sublime Text. And we want to select the export to HTML command. So type export, and you should be able to see an option called export to HTML show export menu. Select that one, and then we're going to, you get a list of options. I'll select browser view color on Mac and Windows, or Sublime view color on Linux. So with Mac and Windows, that will actually open up your code as HTML in the browser, which is really cool. It will have all the syntax highlighting, will have line numbers, be all fancy, all singing or dancing, etc. And we can then print that to a PDF. On Linux, it will open up the HTML code, and we can then right-click that and view that in the browser. Okay, to print to PDF, what we can do is use the browser. So I'm using Firefox in this case. So from the print menu, choose print to file, type in a file name, click print. Presto, we have a PDF copy of our code, nicely syntax highlighted, etc. And that PDF file is what you would submit in order to get feedback. All right, we're done. So we've had a look at all of the tools that you need to install, and you've seen how to use Sublime Text to write your code and to export that code to HTML. You've seen how to use the terminal to compile your program using the free Pascal compiler, and how to run that program. And we've looked then at using the web browser to print your code to PDF. So that's pretty much everything we need to be able to do. Now we can focus on what we actually do inside that program's code. And that will be what this unit's all about. So thank you very much. I hope that helps. And if you have any problems with the installation, feel free to contact us on the discussion board, etc. All right, good luck.
This has been a Swinburne production. Swinburne University of Technology.
Hello, and welcome to this podcast in which we're going to look at installing the tools you need for introductory programming in macOS. Okay, on macOS, there isn't that much you need to install, so this shouldn't take too long. What we're going to have a look at is installing Xcode. Once we have Xcode installed, we'll install the free Pascal compiler. We're going to use Pascal for the first part of this unit. And so this is the compiler that will compile those programs for us. We will then install Sublime Text, inside which we'll install the package control utility and a tool to export to HTML. This will enable us to print our code to PDF quite easily, because Sublime Text doesn't include printing to PDF by default. Once we've done that, we'll show you how all these tools work together in order to create a small Hello World program. All right, let's get started. First of all, what you're going to need to do is install Xcode. We're not actually going to use Xcode directly, but it has all of the development tools that you need on macOS. So to start installing Xcode, open up the App Store and search for Xcode. When you've located that, you'll need to, it's free, so you need to purchase it for free, and then download and install it. Now that'll take a little while, so I'll skip over that, but just wait for it to download and install. All right, once the install has finished, what we need to do is open up Xcode so that it can finalize its installation. So you'll need to accept a few things. Once that's done, wait for the install and close Xcode. We're not actually going to need to use Xcode directly. All right, to finish off the install, we need to set up the command line tools. So open terminal. If you go up to the spotlight window, so if you just click the magnifying glass at the top right corner, that's probably, or command space on the keyboard, that's probably the easiest way to execute your programs. So if you type in here, terminal, you'll see the terminal program. Select that or press enter on the terminal program, and this will open the terminal. And this is where we can execute command line instructions. Now, the command line instruction we need to set up the Xcode tools is Xcode -select, all one word, space -- install. So this runs a program called Xcode select and tells it to install. So -- install is an option to the Xcode select program, and it tells it to set up the command line environment. That'll pop up a window, and you can click through those prompts, and it will go ahead and install the command line environment. So wait for that, and then we'll move on to install the next tool. The next thing we need to install is the free Pascal compiler. As I said, we're going to be using Pascal at the start of the unit in order to compile the programs we create using the Pascal programming language. So you should have a disk image, a free Pascal disk image. If you open that disk image, inside it you'll see a package file, which is an installer. Double click that. What you actually might need to do, because if it's not signed, right click it and choose open, and then you're verifying that you know what you're doing. Click open again, and it will open or start the installer. Follow the prompts, just click through those, and it will go ahead and install the free Pascal compiler. That's all we need to do for that one. Next, we need to install Sublime Text. This is going to be our text editor. Once again, this will be in a disk image, so open the disk image. And to install this, it's the same way you install most applications in macOS. You just drag the Sublime Text application onto your applications folder, authenticate if you need to, and we're done. So installing Sublime Text is super simple. Now, we need to run Sublime Text in order to install package control, which is the next thing we're going to look at installing. To open Sublime Text, once again, the easiest way to do that is just to click Spotlight, so Command space, or click the magnifying glass at the top right corner, and just type SUBL for the start of Sublime Text, and you should see Sublime Text in the options there. You can press Enter or click it, and it will open Sublime Text. And we're ready to install the next tool. Okay, now to install package control. Open your web browser and search for Sublime Text Package Control. When you get the Google page that lists that, it should show you the installation page directly. Go straight to that page, save a bit of time. And what we can do is, if you scroll down, you can see that it gives you some code that you need to run in order to install package control. So it's actually really simple. If you just copy that text, just select it all, right-click and copy, or Control-C, Command-C, etc. to copy, then switch back to Sublime Text. And from View, show the console. This is where we can type some commands directly. So if we paste that command into that little text box down the bottom there, press Enter, then it will install package control. So it's not too hard. You've just got to wait a little bit. Once it seems to have installed correctly, this one doesn't show you much progress, but it'll take maybe a minute or two to install. Once it's done, you've got package control installed. So hide the console, and we can now use package control to install another package. So package control is a utility that lets us install what are called packages inside Sublime Text. And these packages add extra features to the text editor. And the one that we need is the feature that allows us to export our code to HTML. One thing that Sublime Text doesn't have is the ability to print things directly. So what we're going to do is export our code to HTML and then use your web browser to print it to a PDF file, which you can then submit as part of your weekly assessment for the unit. All right, so inside Sublime Text, to run the different commands inside Sublime Text, what we do is hold down 3 keys. On Mac, you need to hold down Command-Shift-P. With those keys held down, it'll pop up a little box into which you can type the command that you want to execute. So we're going to use package controls install package command. We could type any part of that. Probably the easiest bit is to type install. So type install, and you should see the option package control install package. Select that and press enter. That will run that command. This brings up another menu once it's updated the packages. And that menu allows you to select which package you want to install. So you can have a look through there. There's heaps of stuff that you can install. Sublime Text is a really great text editor to use. In this case, we want the export HTML package. So type export, and you should be able to see export HTML. Select that, press enter, and it will go ahead and install the export HTML package. You can see the progress this time down the bottom left. So that's nice. You'll see that install. We're all done. We'll show you how to use this in a minute when we do a walkthrough of the language and the tools. All right, now we can use all of this stuff we've installed to create a program. So open Sublime Text, and we can create a new file, and we'll save it as helloworld.pas. PAS stands for Pascal, and that will tell Sublime Text that this is Pascal code, and it will syntax highlight that with that language, with the rules for that language. One thing to make sure you do is don't put a space. So it's not hello space world, it's hello world, one word, .pas. That's all just one word. The terminal and lots of programs you run from the terminal are difficult to work with if there are spaces in file names or spaces in path names. So avoid spaces pretty much for all file names. All right, I'm going to save mine into the desktop, but you might want to save yours into a documents, my documents folder or something like that. All right, we can now type in our program's code. And as you do this, you should see the text editor highlighting different parts of the text in different colors. This is because it understands the Pascal programming language and can therefore use that to give you some feedback on how you're going. So this program is program hello world, semicolon. We then have begin. I usually put the end in straight away. The end matches the begin. So we start at the begin, we end at the end, put a full stop at the end, and we will run one instruction, which is to call the write line procedure. So we type write line, write ln, no spaces, notice, open brackets, and then in single quotes, we'll put the text hello world, exclamation mark, close bracket, semicolon. So that tells, well, that's our instructions to the compiler for what we want the program to do when it creates it. All right, now we've got our code. Save that file. Use Control S or Command S on Mac. Alternatively from the file menu, but get used to the shortcut keys. It'll save you time. All right, now that the file's saved, we need to compile the program. So you need to do this from the terminal. So open the terminal. On Windows, use MSys or the MinGW terminal. And we need to CD to the location where you've saved the files. So I'm going to CD to my desktop. On Linux or Mac OS, it would just be CD space /users/acane/desktop. And I can just usually shortcut that on Linux and on Mac just by using CD desktop, as I'll start in the users acane directory. All right, now let's use the compiler to compile our program. Run fpc space -s2. That's an uppercase S, not a lowercase one. Uppercase S2. And hello world.pas. That tells the compiler to run itself. So we're running the compiler. The -S2 gives it options to tell it how we want it to compile the file. And S2 stands for a more advanced version of the syntax. So syntax 2, not the basic syntax, but the more advanced syntax. And hello-world.pas is the file that we're going to compile. So it's going to compile the hello-world.pas file and create a program for us. So when that runs, you can see we've got a hello world executable created on my desktop. So we can run that from the terminal /hello world and press enter. You could double click the file as well, but the terminal window will probably close straight away, so you won't actually see what it's done. So it's easier to run it in this terminal. Okay, so that's creating a program, compiling it. The other thing that you'll need to do as part of this subject or part of a unit will be to submit code. And when we submit the code, what we're going to want is a PDF version of the code so that we can annotate it to give you feedback, etc. So go back to Sublime Text and press Control-Shift-P on Windows and Linux, or Command-Shift-P on Mac OS. And this will bring up that menu of commands that we can tell Sublime Text. And we want to select the export to HTML command. So type export, and you should be able to see an option called export to HTML show export menu. Select that one, and then we're going to, you get a list of options. I'll select browser view color on Mac and Windows, or Sublime view color on Linux. So with Mac and Windows, that will actually open up your code as HTML in the browser, which is really cool. It will have all the syntax highlighting, will have line numbers, be all fancy, all singing or dancing, etc. And we can then print that to a PDF. All right, to print our code to PDF, what we need to do is switch to the Safari browser, and we can now print it by choosing File, Print. And from here, if you notice down the bottom left, you can see a PDF button. If you choose PDF, Save as PDF, this is available on all print dialogues in macOS. So you can print anything to PDF. It's really simple. So PDF, Save as PDF, enter the file name that you want, and choose the destination, desktop for example, and click Save. And that will go ahead and create a PDF for us. Presto, we have a PDF copy of our code, nicely syntax highlighted, etc. And that PDF file is what you would submit in order to get feedback. All right, we're done. So we've had a look at all of the tools that you need to install, and you've seen how to use Sublime Text to write your code and to export that code to HTML. You've seen how to use the terminal to compile your program using the free Pascal compiler, and how to run that program. And we've looked then at using the web browser to print your code to PDF. So that's pretty much everything we need to be able to do. Now we can focus on what we actually do inside that program's code. And that will be what this unit's all about. So thank you very much. I hope that helps. And if you have any problems with the installation, feel free to contact us on the discussion board, etc. All right, good luck.
This has been a Swinburne production. Swinburne University of Technology.
Hi, welcome to this podcast in which we're going to look at the installation of programming tools for Windows. So what do we need? Well, we're going to start by installing the Google Chrome browser if you don't already have that. Then we need to install the MinGW development tools and a console2 program which will allow us to interact with those tools. We'll then install the free Pascal compiler, Sublime Text with the package control and the ability to export to HTML, and we'll have a look at creating a small Hello World program that uses all of these tools. Now remember, you only have to install these once. All right, the first one, installing Chrome. Open up Internet Explorer and navigate to the google.com/Chrome website. And from here, you can download the Chrome browser and accept the conditions to install. Follow the on-screen prompts, and this will go ahead and install Chrome. We need to use Chrome as it will allow us to print our code to PDF. It includes a built-in save to PDF file option, which isn't available in Internet Explorer. When Google Chrome has finished installing, you can close Internet Explorer and close Chrome down and just return to the desktop. Okay, the next tool. Next thing we need is MinGW. Now this is going to give us some development tools that we need to be able to interact or to create some of the programs we're going to create. Now this is a little more involved than all of the other things you're going to have to install, so take some time with this. Make sure you follow all the steps. Now, the first bit's easy. We run the installer and we follow the prompts. Now this actually installs a separate configuration tool from which we can choose to install different tools that are available in the MinGW toolset. So once the configuration tool is installed, what you need to do is install the MinGW development tools, the MinGW base tools, as well as the MinGW G++ tools. So if you select those three options, just mark them for installation. You then go ahead and apply that installation, and the installation tool will go ahead and download all of the files it needs, configure those and set those up for your computer. It will take a while to download and install, so you can just leave that. I'll fast forward through that, and when it's all done, we'll move on to the post-installation setup. So we need to do a few steps to get MinGW set up correctly after the install's finished. All right, so now your install's finished, we need to run a post-installation setup script. So open up your Explorer and navigate, the file Explorer that is, and navigate to c://mingw. So navigate to that directory, and when you get there, scroll down and you'll find the msys directory. Double click to go into that one, and then double click to go into the 1.0 directory. In here, you should be able to see an msys program. If you double click that, you'll get a prompt, a terminal window that appears, and we can type commands into this and get the computer to do different things for us. This is the kind of thing that we're going to be using to compile and run all of our programs. This is the basic MinGW or msys terminal. We're going to install a separate one as part of these steps, one that has a few extra features like copy and paste, which this tends not to work too well with. All right, so once your terminal's open, you need to type a command. And the command we're going to type is cd space /c/msys/1.0, and then hit the enter key. What we've told the terminal to do there is to change directory. That's what CD stands for. So change directory into C drives MinGW msys 1.0 folder. So the same place we navigated to in Explorer before. Now in this directory, we can run another command, So type /post install, one word, no space, /pi.sh. So that says to look in the post install directory and run the pi, which I guess stands for post install.sh file, which is a script file that contains a set of steps that it needs to follow. Now this in post install will go ahead and install or set up all the things MinGW needs to work correctly. So press enter and it'll prop up some text. You need to follow the prompts so that you're going to install it. And when it asks you for the directory, type in C:\\min_GW and press enter. That's so that it knows where the basic or all of the other MinGW tools are installed. We're setting up the MSys tools here. All right. Once you're done with that, you can close the MSys window, and we'll open another one just to make sure that that post install is all set up and ready before we open it. Okay. Now we're going to install the console2 program. To do that, type mingw -get, one word, space install space msys -console and press enter. This is going to get all of the files you need to be able to install that console2 program. It will download those, just wait for that to finish. And when that's finished, what we type is console -config, enter. And that will go ahead and configure the console program and get it ready for us to actually use. When that finishes, we now have our console2 program. It will be called MSys so that it relates to the MinGW's MSys console. We now need to find that program, and the easiest way to do that is to use your Explorer. So we can actually open an Explorer window in the current directory by typing Explorer space / and pressing enter in the terminal. Now it will run the Explorer program. / means the current directory. So run Explorer and tell it where the current directory is. And you'll see that pop up a window, and inside that we've got the MSys program there. You can double click that and that gives you the new MSys terminal window. And you can see we can copy and paste, and you've got right click, get a few extra options there. It's a bit nicer to use. Now, you're not going to want to navigate to this directory every time you need to run the MSys program. So best idea is to right click the MSys program and pin that to your start menu. This will make it easy to access from your start menu. So if we go to the start menu, you can see it over there on the right as MSys. If you click that, you'll get the MSys terminal. All right, that's by far the hardest part of this setup finished. So we're nearly there, bear with us. All right, now we need to install our compiler. We're going to be using the free Pascal compiler to start with in this course. We'll use some other compilers later on. Run the installer and follow the prompts. It's pretty simple. One thing you could do is remove the one that places a IDE shortcut on the desktop. We're going to use a different text editor, not the one that they provide. So just remove that option. Leave everything else the same. Click next, etc. Accept what you need to accept, and finish to install the script. It will go ahead and install the compiler. All right, done. That one was easy. So next is Sublime Text. This is just as easy. Run the installer, follow the prompts, and we're done. So when that's installed, run the Sublime Text program, and we're going to need to install a few extra options inside Sublime Text. Okay, now to install package control. Open your web browser and search for Sublime Text Package Control. when you get the Google page that lists that, it should show you the installation page directly. Go straight to that page, save a bit of time. And what we can do is if you scroll down, you can see that it gives you some code that you need to run in order to install package control. So it's actually really simple. If you just copy that text, just select it all, right click and copy, or Control C, Command C, etc. to copy, then switch back to Sublime Text. And from View, show the console. And this is where we can type some commands directly. So if we paste that command into that little text box down the bottom there, press Enter, then it will install package control. So it's not too hard. You've just got to wait a little bit. Once it seems to have installed correctly, this one doesn't show you much progress, but it'll take maybe a minute or two to install. Once it's done, you've got package control installed. So hide the console, and we can now use package control to install another package. So package control is a utility that lets us install what are called packages inside Sublime Text. And these packages add extra features to the text editor. And the one that we need is the feature that allows us to export our code to HTML. One thing that Sublime Text doesn't have is the ability to print things directly. So what we're going to do is export our code to HTML and then use your web browser to print it to a PDF file, which you can then submit as part of your weekly assessment for the unit. All right, so inside Sublime Text, to run the different commands inside Sublime Text, what we do is hold down 3 keys. So on Windows, you need to hold down Control-Shift-P. With those keys held down, it'll pop up a little box into which you can type the command that you want to execute. So we're going to use package control's install package command. We could type any part of that. Probably the easiest bit is to type install. So type install, and you should see the option package control install package. Select that and press enter. That will run that command. This brings up another menu once it's updated the packages, and that menu allows you to select which package you want to install. So you can have a look through there. There's heaps of stuff that you can install. Sublime Text is a really great text editor to use. In this case, we want the export HTML package. So type export, and you should be able to see export HTML. Select that, press enter, and it will go ahead and install the export HTML package. You can see the progress this time down the bottom left. So that's nice. You'll see that install. We're all done. We'll show you how to use this in a minute when we do a walkthrough of the language and the tools. All right, now we're done. The very last step we need to do is to restart your computer. Some of the stuff that we've installed in Windows means that the computer needs to be restarted. Don't skip that. If you do, stuff won't work. Not much fun. So just restart, everybody will be happy, and I'll see you in a minute. All right, now we can use all of this stuff we've installed to create a program. Good thing is, you don't have to install any more tools. Everything you've got, when it works, will work for the rest of the subject. So open Sublime Text, and we can create a new file, and we'll save it as helloworld.pas. PAS stands for Pascal, and that will tell Sublime Text that this is Pascal code, and it will syntax highlight that with that language, with the rules for that language. One thing to make sure you do is don't put a space. So it's not hello space world, it's hello world, one word, .pas. That's all just one word. The terminal and lots of programs you run from the terminal are difficult to work with if there are spaces in file names or spaces in path names. So avoid spaces pretty much for all file names. All right, I'm going to save mine into the desktop, but you might want to save yours into a My Documents folder or something like that. All right, we can now type in our program's code. And as you do this, you should see the the text editor highlighting different parts of the text in different colors. This is because it understands the Pascal programming language and can therefore use that to give you some feedback on how you're going. So this program is program hello world, semicolon. We then have begin. I usually put the end in straight away. The end matches the begin. So we start at the begin, we end at the end, put a full stop at the end, and we will run one instruction, which is to call the write line procedure. So we type write line, write ln, no spaces, notice, open brackets, and then in single quotes, we'll put the text hello world, exclamation mark, close brackets, semicolon. So that tells, well, that's our instructions to the compiler for what we want the program to do when it creates it. All right, now we've got our code. Save that file. Use Control S or Command S on Mac. Alternatively from the file menu, but get used to the shortcut keys. It'll save you time. All right, now that the file's saved, we need to compile the program. So you need to do this from the terminal. So open the terminal. On Windows, use MSys or the MinGW terminal. And we need to CD to the location where you've saved the files. So I'm going to CD to my desktop. On Windows, that will be CD /C or CD space. So the space separates the commands, the parts of the command on the terminal. So CD space, where do I want to go? /C /users Acane desktop. It's Acane, that's because that's my username. So your username will be different. Type the appropriate thing in there. All right, now let's use the compiler to compile our program. Run fpc space -s2. That's an uppercase S, not a lowercase one. Uppercase S2. And hello world.pass. That tells the compiler to run, or to run itself. So we're running the compiler. The -S2 gives it options to tell it how we want it to compile the file. And S2 stands for a more advanced version of the syntax. So syntax 2, not the basic syntax, but the more advanced syntax. And hello world.pass is the file that we're going to compile. So it's going to compile the hello world.pass file and create a program for us. So when that runs, you can see we've got a hello world executable created on my desktop. So we can run that from the terminal ./hello world and press enter. You could double click the file as well, but the terminal window will probably close straight away, so you won't actually see what it's done. So it's easier to run it in this terminal. Okay, so that's creating a program, compiling it. The other thing that you'll need to do as part of this subject or part of a unit will be to submit code. And when we submit the code, what we're going to want is a PDF version of the code so that we can annotate it to give you feedback, etc. So go back to Sublime Text and press Control-Shift-P on Windows and Linux or Command-Shift-P on Mac OS. And this will bring up that menu of commands that we can tell Sublime Text. And we want to select the export to HTML command. So type export, and you should be able to see an option called export to HTML show export menu. Select that one, and then we're going to, you get a list of options. I'll select browser view color on Mac and Windows or Sublime view color on Linux. So with Mac and Windows, that will actually open up your code as HTML in the browser, which is really cool. It will have all the syntax highlighting, will have line numbers, be all fancy, all singing or dancing, etc. And we can then print that to a PDF. All right, now in your browser, we can print it to PDF. So in Windows with Chrome, what we can do is from the file menu, choose print, so print, and change the destination. Instead of being a printer, change that to save to a PDF file. That makes it super simple. It'll do all the work for us. We then click the save button, type in the file name that you want, and presto, we have a PDF copy of our code, nicely syntax highlighted, etc. And that PDF file is what you would submit in order to get feedback. All right, we're done. So we've had a look at all of the tools that you need to install for Windows. And you've seen how to use Sublime Text to write your code and to export that code to HTML. You've seen how to use the terminal to compile your program using the free Pascal compiler and how to run that program. And we've looked then at using the web browser to print your code to PDF. So that's pretty much everything we need to be able to do. Now we can focus on what we actually do inside that program's code. And that will be what this unit's all about. So thank you very much. I hope that helps. And if you have any problems with the installation, feel free to contact us on the discussion board, etc. All right, good luck.
This has been a Swinburne production. Swinburne University of Technology.
Hi and welcome to Swinburne Codecasts. I'm Andrew Kane.
And I'm Ruben, and in this video we're going to be looking at programs and sequence.
So far, we've seen how we can compile programs from the terminal using the command line compiler and using our build script for our Swing game programs.
Which is cool, but what exactly can I code into my programs?
Well, there's a whole lot of things that we can code into our programs, but I think where we want to start is to understand that the computer runs our programs as a sequence of instructions. And so I think that's where we can get started.
Okay. What I would like to do then, using Swing game, as you said, is I'd like to make a basic illustration of my house. So can we do that?
Yeah, let's get started with that. So here what we've got is an empty program, has no instructions in it at the moment, but between the begin and end, we can provide a sequence of instructions for the computer to execute. The one instruction we can use at the moment is going to be called a procedure call.
And what exactly is a procedure?
So a procedure is like a small program. It's actually another list of instructions that performs a certain task. So let's add in two instructions to start with. Open graphics window and delay. So open graphics window, we pass it 3 values, and when we call that procedure, it has all of the instructions to make a window appear on your computer. Whereas the delay procedure has all of the instructions to tell your computer to wait for a certain amount of time. And so we pass in 5,000 for delay, which is the number of milliseconds to wait. With open graphics window, we pass in 3 values, being the title of the window and the window's width and height.
Cool.
So if we switch to the terminal now and compile and run this, we should see that program work. And so when we compile it, we use build.sh. You have to use cd to change into the directory first, remember that. And when we run it using the run script, it appears and we can see the window for 5 seconds.
But it doesn't really have much in it yet. So my idea was to draw our house. So where do you suppose we could start with that now that we've got our graphics window and a delay?
So with this, remember it's a sequence. So we want to show the picture after we've opened the window, but before we delay.
Okay.
So we would put the instructions in between. So we could start off by let's clear the screen to white. So there is a procedure called clear screen. We call clear screen. It's going to clear that window to white. And we can then add in one more, which is refresh screen. When we call refresh screen, it shows everything that has been drawn previously onto the screen. This is why we can draw part of your house one piece at a time, but then only show the whole picture when it's finished.
Cool.
So let's switch back to the terminal, compile with build script, run with the run script, and we can now see the window open and the screen is cleared to white.
Yeah, yep. Alrighty, well, let's start off with putting in, say, a hill. So how could we do that?
So there's a number of drawing procedures. So there's fill and draw procedures. So for each a number of different shapes. So we have fill ellipse, fill rectangle, fill triangle, as well as draw ellipse, draw rectangle, draw triangle. Each of these takes a different number of parameters based on the shape. So the ellipse takes a color, as well as the X and Y position, which is the distance from the left-hand side of the screen and the distance from the top of the screen. And then they take in the size. So an ellipse, we need to know the width of the ellipse, and the height of the ellipse. And so that's those extra parameters there. So in this case, it's going to draw the ellipse at 0, 400. So 0 pixels from the left, but 400 pixels from the top. It's going to be 800 pixels wide and 400 pixels high.
And it's going to be bright green.
Yeah.
Cool.
So now if we run that, we can see that circle drawing.
Sweet. And that's exactly what I do see there. So now I could draw the rest of my house by adding in a rectangle and a triangle for the roof.
Yeah, that's correct. And so the key bit to remember, though, is that you've got to put it in the right sequence. So if you put the drawing of the rectangle before the drawing of the ellipse, then the hill would appear in front of the house. So the house would be behind the hill. Whereas if you do it the other way around, the house will be on top of the hill.
Cool. So it's sequenced just like you said. We fill the ellipse first, and then we can fill the base of the house, and then we can put the roof on.
Yeah, that's right. And so the key bit to remember for programs run as a sequence of instructions. It starts at the top, and as the program executes, Each instruction runs one after the other. So when we run this program, what happens? The window opens, it clears the screen, it then fills the ellipse, it fills fills the rectangle,
Yep.
then fills the triangle, refreshes the screen, which shows everything to the user, delays for 5 seconds, and after 5 seconds, the program ends because we've reached the end of the instructions.
Too easy. So I guess that wraps that up then.
Yep, so that's it for programs and sequence. Our future videos.
So we've got a video on creating your own procedures. So now that you have an understanding of what they are, you can go ahead and create your own. And if you haven't checked them out already, you should check out the videos on compiling your code as well as navigating with the terminal.
Okay, hope you've enjoyed that, and we look forward to seeing you again soon.
Bye.
Bye.
This has been a Swinburne production. Swinburne University of Technology.
Hi, and welcome to Swinburne Codecasts. I'm Andrew Kane.
And I'm Cliff, and in this video we'll be looking at creating our own programs and procedures.
So far, we've seen how to compile programs and have those programs, as a list of instructions that perform things in sequence. And we've been able to call other procedures to perform tasks like some drawing things as well as printing things out to the terminal.
Yeah, I've been getting a hold of this calling procedures situation. I like it; it's useful, but I think it'd be really good if I could create my own procedures. That way I could create a little bit more meaning in my own code. I could reuse sections of my own code. All of these kinds of things.
Yeah, well, definitely that's what this video is about.
Awesome.
We can create our own procedures, and that can help you sort of encapsulate all of the actions needed to perform different tasks in your program. And those procedures will be able to be reused. You don't have to code them multiple times. Get it right once and just call it anytime you want to.
Okay. So here I've got this this Wii program that I've been making. I was tasked with making a Morse code program. Well,
Tell me what it's saying.
It's meant to say YOLO.
Okay.
You can't see that?
Can you?
No. That's really one of the problems. And I made tons of mistakes when I was doing it anyway, and I was having to refer back to the Morse code alphabet. And I think there might be a better way to do this.
Yeah. So, one thing we could do here is break this up into procedures. And so we can have sort of the instructions in a main procedure to start with. But, it's affected. What we've got is pretty much the same here. Now, what are the main sort of tasks inside your Morse calling program? What are the most basic ones? Maybe we'll start there. We can then work up to more complex procedures.
Okay. Well, looking at the smallest sort of package of information in there would probably be the short signal and the long signal and the breaks.
Yeah. Okay. So what we could do is create procedures to represent the actions that need to be performed when those tasks, or when you want those tasks performed. Yeah?
Okay. Yep.
So, in this case, there is only one instruction in each of those. But the good thing is later on, if we want to change how that works, we only got to change it in this one place, and everywhere else would then have that change reflected.
Okay. Yeah, and I can see that the main procedure is a little bit easy to read now, but
we've got the idea now that it's making long and short signals and delays between characters.
Yeah,
it looks a bit more meaningful, but
we've still just substituted each of those characters with my own procedure, so we haven't really changed much of the program. Could I make a procedure to make each letter?
Yeah, so that's definitely what I think we would do next. So what we could do next, instead of just having the long and short signals being called in main, what we could do is create our own procedures to signal each of the different characters.
Oh, so you can have your procedures calling other procedures.
Yes, yeah. So
Oh, sweet. Inception.
yeah, pretty much. Yeah, so now we can see that it's printing. You've got a procedure for each of those, each of the different letters.
Yeah.
And the great thing is you only need, say, like the signal O once. And once you've got it right, it's 3 long signals.
Yeah. Okay.
Yeah,
So
you
I've
can
actually
then call
saved,
it multiple times.
I've saved like 3 lines of code already.
Yeah.
Sweet. And it's much easier to read now in main. You can actually, like, ignoring the signal section, you can see, YOLO. So that's,
Yeah.
awesome.
Yeah. And the great thing now, as I said before, we could actually change the whole way that this works. So at the moment, this is printing out to the terminal.
Yeah.
But, I mean, you'd only have to make a very minor change to have this work with a, like actual audio. So we could change the way the short and long signal work so that they play sound effects using the Swin Game library that we've provided.
And so just by replacing those write commands,
Yeah.
those write procedures with the play sound effect, that will affect all of the, like, the signal Y and the signal O as well?
That's correct, because each of those is actually calling those long and short signal procedures.
I think that would, that's going to save me so much time in development later.
Yeah. Well, the good thing would be if you had a bigger program, if you made a mistake in one of your procedures, when you fix it in that one spot, it fixes it everywhere that called that one procedure. So you don't have to sort of, if you've duplicated the code all over the place.
Yeah. So you can just fix
you don't
it
have to
once
find
and
it
and it
everywhere.
fixes it all, yeah.
Yeah. All right, Cliff, do you want to show us how this one works?
Yeah, sure thing, Andrew. So the program begins, and we start off in the main procedure. And the first thing that it does is it calls the procedure that I made called signal Y. So it heads up here, and then the first thing that it does is calls the long signal procedure.
Okay,
so
yep.
we're jumping around a bit here, but
Yep.
I hope you can bear with me. So we head up here, and the procedure begins, and it plays the sound effect da. After that, the procedure ends, and it returns to the procedure that called it.
And so the signal Y procedure remembers which instruction it's up to. So it now runs.
Short signal.
Yeah.
Yep. So once again, short signal is called. And
So it goes on top of the stack.
That's right. Yeah. So as you can see over here, yep, you've got the signal Y, and then it's
calling,
it's
yeah.
calling short signal. So it begins, plays the sound effect dit.
Yep.
It ends, and once again returns back to signal Y.
Yeah.
So now you said that it keeps track of which line it's in signal Y as well. Yeah, the stacks.
That's right, yeah.
The stacks managing all that. I don't
That's
need
it.
to do
That's
that.
all in the stack. Yes. The compiler's remembering all of these things for us.
Brilliant. Love it. All right. So next thing, I think, oh man, I wish I could remember as good as the stack could. I think we're up to long signal.
Yeah, long signal. Yep.
Yep. So we head back up to long signal. Same situation again. It's called, it begins, plays the sound effect da,
Yep.
ends, returns back to
Signal Y.
signal Y. Long signal again.
Yep.
Man,
I think we get the idea
I'm
now.
so glad
Yeah.
that this is automated. Like if I had
Yeah, I know. It is pretty cool. You just say do this and it does it for you. Yeah. And so now when signal Y ends,
Yep, it's going to return to the procedure that called it,
which was,
main.
that's right.
Yep, so we're back to main. And we're going to call a character delay, so that's just a space so we can
So
separate
it goes
each
up,
of the
yep,
letters.
plays the character delay
Yep.
procedure. And so this is the same, but now, it's just calling fewer of our own procedures.
Yep.
It still calls delay, which is a procedure, and it probably calls other procedures that we don't know about.
Cool.
Yeah. And so the process just continues, doesn't it?
Yeah.
For a signal O, and it calls through all of the different, or in this case, the 3 long signal procedures.
Yep. Character delay, and then signal L, character delay, signal O.
Yeah.
Yeah. Cool.
All right. And then when we've got nothing left on the stack, what must that mean?
Well, I guess if his procedure main has ended, it will go to the end of the program.
Yeah, and that's it. So that's how the program knows when it's over.
Oh, cool.
Yeah. All right. So here is another example. So in our YOLO program, we could put all of the actual
Signals themselves, yeah.
YOLO phrase
Yeah.
into its own procedure, which prints out each of those characters. So if you wanted to say YOLO 10 times,
You don't
just
need 10
write-
lines.
Yeah, that's right.
Well, and all of the accompanying procedures.
Yeah.
Yeah. Okay, cool. Here's one that I've got here that's taken a simple house drawing program,
Yep.
and I've split up all of the sections of the house because calling the swing game procedures did look a little bit confusing in main. I've just separated.
Which just
those
makes it
into-
much clearer, doesn't it? If you look in main, we can see that you're drawing some sky, you're drawing a hill, you're drawing a house.
Yeah, and it means that if I wanted to change the color of the sky, I know exactly where to go.
Yeah,
Which,
yeah.
yeah.
You don't have to work out which one of the different, fill rectangles.
Was it the
draw
rectangle?
rectangles,
Was
yeah.
it the clear screen? Yeah.
Yeah. Cool. All right, that's it for procedures at the moment. We will come back and look at a lot of these things in more detail later to make things even easier.
Okay.
Because that's always the idea. I mean, we're trying to make, do more with less.
That's a good programming principle.
Yes. Yeah. So we will come back and look at all of these and different things we can do with them. But that's the basics of procedures.
What should I check out next?
That's a very good question, Cliff. So next, watch the variables video. Otherwise, if you haven't already checked them out, have a look at our compiling videos, and we have a bunch of setup and install videos as well as a sort of an overall welcome to the series.
Yeah.
All right, I hope you've enjoyed that, and we look forward to seeing you again soon.
See ya.
This has been a Swinburne production. Swinburne University of Technology.
Hi, welcome to Swinburne Codecasts. I'm Andrew Kane.
And I'm Jake, and in this video we'll be looking at variables.
So far, our programs have been a list of instructions inside which the data has always been fixed. So we've actually typed all of our data into the program itself.
And that sounds really limiting. So wouldn't it be great if there was somewhere where we could store our data in our program so that we could maybe change it later?
Well, the great thing is we can use variables. Variables allow us to store data inside our programs. We can then read that data back and change the values inside the variables as well.
Great. So I've actually been writing this program, or I tried to write this program, but when I wanted to get the user's name, I just didn't know how to go about it. So is this a case where we could use variables?
Yes, so we could use a variable here to store the user's name inside the program, and then you can use it later on. And so here we've declared the variable. When we declare a variable, we actually allocate space. We ask the computer to allocate a space to store some data. And so here we give the name to the variable. So this is the username variable, and it's going to store a string, so a piece of data.
And I can name it whatever I like?
That's correct. There are some rules. Basically, if you stick to starting with an alpha character and not having any spaces, you should pretty much be right.
Okay. And what's with the string?
So the string says what kind of data we're going to be storing inside the variable. So a string in this case is textual data. So the name might be Fred or something like that. That's text. We store that inside that. We can store that inside the variable. Other types are things like integers for whole numbers, and you've got other types like double, for example, for real numbers.
Okay, cool. So now that I have this space for my name, how do I put my name into it?
For that, we can use an assignment statement. So anytime you want to change the value of a variable, the only way of doing that is through an assignment statement. Somewhere, there has to be an instruction to say, put a value into this variable. And that's what the assignment statement does. It says the value on the right-hand side, store that into the variable on the left-hand side. So in this case, we're going to call this read string function here, and it's going to return us back whatever the user typed at the terminal. And we can take that and store it into the username variable.
Cool, so that's exactly what I was looking for. So now I have the person's name inside my variable.
Yes.
So now that I have the name, how can I use it? So I want to tell the person that I actually know their name. How do I do that?
Well, the way we can do that is just by using the variable's name inside an expression where we want that value. And what will actually happen is, so in this case, we're writing out that the user's name is an awesome name. That won't print out the text user name. It will print out whatever is stored inside that variable. So here we're saying read the value from that variable and use it at this point in the program.
Cool. So that's exactly what I wanted. That's great. So I've also written this program for my little cousin who's learning at 6 times tables, but it's a bit limited at the moment. I can change it using variables so that I could use any times table.
That's correct, yeah. So rather than having 6 hard-coded in this program and the answers hard-coded, we could actually calculate the answer and use a variable to determine which times table we want to use.
Okay, so we should use an integer variable?
Yeah, so in this case, we can have the times table as a whole number. So the number that we use will be a whole number, so it can be an integer. We can declare a number variable, and we could store... We start off with 6. So we can store 6 in that variable.
Because I want to make sure it works.
Yeah. And then rather than printing out the hard-coded answers here, we can calculate the answer. So the first one would be 1 times the number. And then the second one we can use 2 times the number, etc.
Cool. So what if I want my little cousin to change the number whenever she runs the program?
All right, well, rather than up here where we've got our assignment statement, which is storing the value 6 into number, we could change that to use read integer. So read integer is just like read string. It's a function that we are providing in this case, and it will read in a number that the user types in and return that number to us, and we can store that number into that variable.
So when the program runs, the user can put in the number.
Yes.
But this isn't right because it's saying 1 times 6 still.
Yes. So what we can do here, rather than printing out 6, because now that we're actually using a number that's going to change as the program goes, we can, in that place, put the value of the number variable. Right. So we're going to print out 1 times the value of whatever is in the number variable equals 1 times that value, and then 2 times, etc. for the other ones.
Cool. Perfect. So now that she's getting a bit better at her times tables, is there a way that I could let her start at any number, not just 1 every time?
Well, yes. So what we could do is use another variable. So in this case, we've got our number variable, which is storing our integer, but we could also create a second variable, maybe we'll call that the multiplier, and that gives us 2 separate variables. So each variable stores its own value, like 2 placeholders.
Cool.
We could then read in another integer, so your cousin or whoever it was, sorry, I've forgotten, can enter in whatever they want as the starting value. We can store that using the assignment statement, store that in the multiplier, and then we can use that multiplier in our calculations. Now, one thing we will have to do there is increment the multiplier between each one of the values that we're printing out. And so we can actually do this. Multiplier is assigned multiplier plus 1, and that might seem a little strange if you think about it from a mathematical point of view. But what this is doing, you got to remember, is the assignment statement. So it's first executing the right-hand side, which is multiplier plus 1, and then storing the value in the left-hand side.
So if I started at 20, it would now go to 21.
Yeah, and then it would go to, when we run it again, it would go to
22.
Yeah.
Cool.
So Jake, did you want to talk through how this works?
Yeah, sure. So when we start the program, we jump straight to the main.
Yep.
And when we declare our variables, we're declaring a number variable and a multiplier variable.
Yeah, so it's going to allocate space for 2 integer variables. Now the type here determines how big that space would be. So these are 2 variables big enough to store 1 integer in each variable.
Cool. So then when we run to the next instruction, we are assigning an integer to our number variable.
Yeah, so the result of calling this read integer function, so whatever the user types in, whatever number they type in at the keyboard, will come back, and that number will be stored into the number variable. So what number do we want to...
So let's say we store 53.
Yep, so 53 would then be assigned to the number variable. And then we go to the next instruction. So it's going to execute read integer again, ask the user what number do we want to start at.
So my cousin's like really good, so I want to do 27.
Okay, cool. So 27 will then be assigned to the multiplier. So that value is put, the way you can think about it is like the variable is sort of like a box. And this is putting the value into that box.
Cool.
Yeah, so put the value 27 into the multiply box.
So this line prints out the equation.
Yeah, that's right. So what it does is when it prints it out, it's going to print out, so we've got multiplier first, so it reads the value of the multiplier variable there. So that's going to be 27. Then it prints out the x. We then read the value of the number variable. So that's 53. Yep. Equals, and then it's going to print out the result of this expression. So multiplier times number, it has to be calculated before it prints it out.
Right.
So it's what is the value of multiplier?
27.
Times what's the value of number?
53.
So that is
1431.
cool. So it's going to print out 1431.
Cool.
Now on the next line, we then need to increment the multiplier because we've already done 27 times 53. We now want to do
28 times 53.
Yeah, that's right.
So we add 1 to the multiplier.
Yeah, so this adds 1 to the multiplier. So multiplier is currently
27
plus 1 is
28.
store 28 in the multiplier.
Right. Cool.
So now the multiplier is 28. When we do the equation again, we print out the multiplier, which is now
28
yep,
times 53.
times the number, which is 53, yep, equals multiplier times number. So multiplier is
28
times 53 is
1484.
1484. Excellent. You seem very good at this, Jake.
Well,
All right, so on the next slide now, we now need to go to the next multiplier, yeah?
right. So we do the same thing again.
Yeah, so this time reads the value of the multiplier, which is,
28,
yep, add 1.
29
Yeah, store that in the multiplier. So now the value of the multiplier variable is 29.
times the
And
number.
we repeat that, so the outputs, I think you get the idea now.
Yeah.
The output outputs the value from the multiplier variable, 29, times the number, which is 53, which is,
Something like 1537.
yeah, what about 32 times 53? We can
Don't put me on
calculate
the
that one
spot.
later. All right, so this would then continue on until it gets to the end of the
Yeah,
instructions.
okay. Cool.
Yeah. Now there is actually a way we could improve this code using a loop, but we can have a look at that later.
Cool.
Okay, here's some additional examples where we declare different variables. So here we have a user age variable, which stores an integer.
And we have a user height variable, which stores a double.
So a double is a real number, so like 0.5 or
Cool.
10.3
Yep.
or 1.0.
Right.
Yeah, anything, if you want a decimal part
a
to it,
double.
then yeah.
And user student, which is Boolean. What's a Boolean?
So Boolean is a type that allows us to store one of two values, either a true or false value. So you could think of it as true, false, or yes, no, those sort of things. So here we case it, is the user a student? So the answer is true or
Yes.
false, or the
Or
answer
no.
is, you can think about yes or no is another way to think about it.
Cool.
Okay.
Another example is the smiley face program.
Yeah, so this one calculates the positions of circles. And so we can use some variables and we can calculate whereabouts the circles should be positioned on the screen.
Cool.
Okay, that's it for variables. Variables allow us to store data in our program. Whenever we declare a variable, we are allocating space, so we're creating the variable, we're asking for space. We use the name to refer to that variable. You can put values into the variable using an assignment statement. And you can read the value out of the variable by just using the variable's name in an expression.
So next, why don't you guys have a look at our functions and procedures video or our parameters video.
There's also the looping video after you've watched those to have a look at another way of doing that times table thing a bit more easily. So
Cool.
it could potentially loop forever.
Great.
All right, hope you enjoy those, and we look forward to seeing
This
you
has
again
been a
soon.
Swindle production. Swinburne University of Technology.
Hi, and welcome to Swinburne Codecasts. I'm Andrew Kane.
And I'm Cliff, and in this video we'll be looking at adding parameters to procedures.
So far, our programs have been able to have procedures that perform tasks, but they're always sort of a fixed task. The same actions are always performed.
Yeah, wouldn't it be great if we could pass data to the procedures to allow those procedures to have some flexibility?
Well, Cliff, the great thing is we can use parameters to pass data into our procedures.
Oh, cool. I've got this program here, and I quite like it. It draws a smiley face emoji on the screen.
Yep.
And at the moment, it's really cool. I have learned so far that I should be using a procedure for it, so I made a procedure just for it.
Yep.
And as you can see in the code here, like I've called it 2 times, but there's only one smiley appearing on the screen.
Okay, well, I mean, I think the start of our problem is if we look at your draw smiley procedure, we've got a lot of sort of magical numbers there.
Are they good? Do they do magic
no.
for us?
No, they're not good.
So
they're magic because I have no idea what they mean.
Okay.
Yeah. So what we should probably do is, and if you want to change things, we can't have them literally typed into the code. So these are literal values.
Okay.
Meaning it's always the number 300. If you want the number to change, you could use, of course,
variables.
Yes.
Okay. So, but that still doesn't. I still don't understand why there's only one smiley on the screen though. Like I'm clearly drawing it twice. Where's the other one?
Well, they're both drawn at exactly the same place.
Oh,
so
okay.
there's just one on top of the other.
Okay.
Yeah, so they're both there. You just
All right.
can't see them.
So looking at the draw smiley procedure here, I've got a couple of these numbers that I think I can replace with local variables within the procedure.
Yep. All right.
So something like this, like I know that I'm giving it the center position for the circles because it's basically just a whole bunch of circles drawn over the top of each other.
Okay, all centered at a location on the screen.
That's right. Yeah. So I've made here the center X and center Y values, so I can try and arrange the pictures around that.
Yep.
But it's still only drawing one smiley.
Yeah, well, because they're always at 300, 300. So this is where we could use parameters. So at the moment, center X and center Y are local variables, so they exist only inside of draw smiley. So when draw smiley starts, it creates those variables.
Okay, yep.
Which is good, because mostly things should be local variables like that. But in this case, what you actually want to do is have main tell draw smiley what the values for center X and center Y should be. So
Okay.
instead of always being 300, 300, main could pass in different values.
Okay.
It's actually really simple to do. What we can do is move these variable declarations here into the brackets at the top of the declaration
Okay.
of the procedure.
So
and so that effectively makes them parameters. Those brackets there are where we place parameters. And they're just variables that have this special property that they're provided a value when the procedure is called.
So are they still considered local variables for the procedure?
Well, they're now parameters.
Okay.
And
Cool.
parameters are local to the procedure,
Yep.
but they're special. They're slightly more special. So a parameter is a local variable, but one that has its value provided in the procedure call. So when we
Okay.
execute the procedure call now, down the bottom here, we also have to change the way we call draw smiley. So draw smiley now says, you must give me 2 pieces of information. You have to
Okay,
give
yeah.
me center X and center Y.
Okay. So yeah, before, even though they were variables, I was still setting it as the one value, but now here using this, I can set each of those variables in the procedure call.
That's correct. Yeah, so where you call draw smiley down here, it passes up now the values, say 150 and 300 would
Yep.
be passed into, so 150 would be assigned to center X,
Yep.
300 would be assigned to center Y.
Okay.
And
So
then that call executes with those parameter values.
does it just do it in the order that we've written it in draw smiley?
Yeah, it's the order.
Okay. Cool.
Other languages have other features, but most languages, it's just purely order-based. Some have name-based, but
Okay.
look, if you deal with this first, later on other
Alright.
languages have
Okay,
different
so I want 2 smileys next to each other.
Yep. So the way we can call that is just to call draw smiley twice and pass in different parameter values. So the second time, the procedure would have different values.
Okay.
And of course, this means that we could draw as many smileys as you want. So we could draw a smiley here, or here, or here, or here,
Okay. Yeah.
etc. So you can draw smileys pretty much anywhere you want to.
Yeah. Okay. That's awesome. What if I wanted to change the size of the picture?
Okay, well then this would just be another. What would it be?
Another. You can add parameters for that.
Yeah, well, you can have as many parameters as you want. So let's have a look here. You've got, for example, clear screen. When you call clear screen, it must have a parameter because you're passing in a value for what color you want it to clear.
Okay. Yep.
Where you've got open graphics window, you're passing in 3 values. So those 3 values are going into 3 parameters. And notice they're different types: a string and 2 integers. Fill circle is taking in a color.
So
three values, this and center X, center Y, and the radius. So you can have as many as you want. Obviously,
so
don't
I've
want
been
to go too
using
crazy.
these all along and just not really knowing how they worked.
That's right. Well, now we can actually use it ourselves.
Awesome. So what I could do is add like a size parameter. That would be the diameter of the face.
Yep.
But in the procedure, I've always used the radius to calculate things when I've been doing the math when I've been hand executing it on a piece of paper.
Yep.
Can we have local variables as well as parameters?
Yeah, definitely. So we could add in a third size parameter, and then you could add, say, your radius as a local variable. So the calling procedure, or whatever's calling this code, would only need to provide 3 values, and then you can calculate any number of other values that you want in order to get this to work.
Okay. Cool. Well, here I've got the local variable radius. It's using the size parameter to calculate that value, which is all cool. It's working perfectly for 300. I've gotten rid of a whole lot of these magic numbers here, which is great. But now when I've sent a smaller size, it's still gone wonky.
That just means your calculations are wrong. So there's no real extra feature here. It's just a matter of sitting down and working out what those magic numbers represent, creating variables for them, and then calculating those values.
Okay.
So I'll let you get to work on that, Cliff.
Okay, well, let me just... I've got this picture here that I've been referring to. So, all right, I think I've got it.
That's very quick.
Yeah. What can I say? I work fast. I've made a bunch of new local variables.
Yep.
So all the things are scaling really, really nicely.
Yep.
And as you can see here, I can...
Yeah, so you've got 3 parameters. You're also able to have a whole bunch of local variables. You can calculate values using the parameters that you've got. You can also calculate other values using local variables or parameters or a combination. And you can pass those into other procedures that you call as well.
0 magic numbers. Looks good.
Well, yeah. Oh, you've still got 2, 3, and 6, but
Okay. Are they allowable?
I'll accept those. Yeah,
Okay.
That's not too bad.
Okay. Cool.
Okay, Cliff, did you want to quickly run us through how this works, maybe just for a couple of the draw smileys?
Yeah, sure thing, Andrew. So we begin at main, and we first open a graphics window and load the default colors and clear the screen to white.
Yep. So each of those are procedure calls.
Yep. Whenever I'm making a swing game program, they're usually the first 3 things in there.
Yeah.
And then we call draw smiley. So we see here that I'm passing in the parameters 150, 300, and 300. Yep. So they're being stored in the center X, center Y, and size parameters. Yep.
Yeah. So this is the bit that we're actually showing off.
That's right. Yeah. So they're all integers. All of those numbers have been stored in there.
Yeah. And it's just like 3 assignment statements, isn't it? Assign this value to that parameter. Assign this value to that parameter. Assign this value to that parameter.
So long as you get the order and the types correct, then everything's going to be
good.
sweet. Inside the draw smiley procedure, first we've got the local declarations.
Yep. So we've got all those parameters already, and that's why they're a bit special, because they got provided with those values
to begin
by the calling procedure.
Yep.
Yeah. And then it goes ahead and creates.
Yep. I've created space for radius, eye offset, eye size, smile scale, and smile offset. They're all integers as well.
Yep.
The procedure begins, and I just do some basic calculations to scale the thing. Based on my original model, So here I've got...
So size divided by 2?
Yep, so size was...
300?
And so that would make radius 150.
Yep. We store 150
In radius, that's right, yep. Once again, we read radius, divide that by 3, and store the answer 50 in I offset.
Yep.
Read radius again. As you can see, this is why I needed a radius. You know, I've used it over and over.
Yeah.
Yep, so divide that by 6, store 25 in I size. Actually, smile scale and I size end up being the same number, but I made local variables to keep myself sane here.
Yeah.
Just the fact that they're both 25 necessarily mean that would always be the case, depending on the
way you want
the face that you were drawing. Yeah.
Yeah. Okay.
Coincidence, I think.
Yep.
Here we've got. I tried to scale it using a decimal number, 7.5, and it wasn't working. And so.
So the problem here is when you divide the integer by 7.5, which is a real number.
Yep.
It gives you back a real number, and you can't store that in an integer. So it could be something with a 0.25 or point something attached to it. And so what you have to do is actually convert that into an integer. And there's a number of different ways that you can do that.
So I've calculated that value, and I've stored it in the smile offset.
Yep.
So then leading on to the actual drawing of the picture, we've got a call to fill circle. It takes in yellow. It takes the original parameters that were passed, the center X and center Y, and the radius.
So that's our 150, 300, and then 300.
300 again. Yep. And so that draws the actual body of the face, the head, I guess. We call draw circle.
Yep.
This time using color black to give it
that outline.
That's the outline. Yep.
Same spots.
Once again, the same parameters that were passed in.
So we read the value from center X, we read the value from center Y, and we read the value from radius, which is your local variable.
Yep. And then we move on to the smile. Now I got pretty clever with this. This is like two circles overlapping. One of them the background color and one of them the foreground color.
Yeah.
Here we've got a fill circle. Once again, we're reading the values of center X, center Y, and I've scaled this smile using radius minus the smile scale. Okay. So that should keep it all looking correct again, unlike the wonky one.
Yep.
Fill circle here, this is the one that makes it so it looks like a crescent, I suppose.
Oh, okay,
yep. I was quite pleased with the outcome of that.
Looks cool.
Once again, using center X and center Y with an offset again, so that would be reading 150 and 300, minusing that offset. So that's the thing that just moves that circle slightly up to give that crescent effect.
Yep.
Drawing the eyes here, we've just got two black circles for either side. Yep. So
and you got different offsets for the eye position.
Yep, that's right. Because if you remember in the wonky one, that was the thing that was sort of really noticeable.
Yeah.
But yeah, just having these local variables has solved that problem.
Excellent. And so when this ends, we would go on to draw the other smileys, and so we would get those first two to appear, and we can jump down here maybe to where we call the draw smiley with the slightly smaller one. We'll just step through maybe the first few bits to see, so we can see how those new values are calculated.
Yeah, sure. So in this case, the parameters that we're passing are 150 and 300, so that's the same XY coordinates again.
So same center X, center Y are passed
That's right. But now 200's going into the size parameter.
Yeah.
So what that'll mean is basically as soon as the procedure begins again, we've got the radius
What's happened to you?
being divided by 2. Previously it was 150. Now obviously 200 divided by 2 is
100.
Too good. That's obviously
store 100 in the radius. Yeah.
Yep. That's going to change the rest of them because we're all relying on radius. So now I offset's going to be storing 33.
Yeah, because this is using integer division. One integer divided by another doesn't give you any decimal places, so they're all truncated, effectively, just being chopped off.
Okay, now so it will always go down if there's a
okay,
just
drops.
Awesome. I'm sure that will be handy
not
later.
A whole number. Yeah.
Yep. So yeah, eye size now is 200 divided by 6, which is 16. Smile scale
is radius, so 100 divided by 6. But yeah, 16.
Yeah, thank you. Same again for smile, and smile offset ends up being 13.
Yeah. And so those values then go into those different drawing functions in order to make the picture appear the way that we want it to appear.
Yeah. So the smiles, the smileys will be in the same place, but they'll just be shrunk
Different.
down.
Yeah, yeah. And the great thing is now we can, of course, draw sort of any number of smileys to the screen of any size. Anywhere, yeah.
Man, that is awesome. You'll have to show me how you did that effect one day.
Okay. Maybe next week. All right, so that's it for smileys, I was about to say. That's it for parameters. Parameters allow you to provide data to your procedures when that procedure is called. So it's a super convenient way of making your procedures much more useful.
Yeah. I really like the flexibility of that.
Yeah.
What's coming up next?
Well, next we've got functions.
Yep.
So we can have a look at procedures are one way. You call a procedure to perform an action. A function allows you to actually calculate and return a value. We've also got the variables one, but hopefully you've probably already checked that out.
If you haven't seen the variables one, watch that now.
Or watch it before now.
Try and watch it
Come
before
back.
now. Yep.
Yeah, that was good. Otherwise, there's also the next topics material,
Yep.
which is on control flow. So doing things in a loop, like say drawing 1,000 smileys to the screen
Oh, cool.
at
cool.
one time.
Yep.
Yeah.
Oh, sounds like fun.
Yeah. Well, that's it for parameters. I hope you enjoyed, and we look forward to seeing you again soon. Bye.
This has been a Swindon production. Swinburne University of Technology.
Hi, and welcome to Swinburne Codecasts. I'm Andrew Kane.
And I'm Ruben, and in this video we're going to be looking at creating your own functions.
So far, we've been able to create programs that use procedures as a list of tasks that sort of perform an action. We have variables that we can store values in. We also should have looked at how to pass values to procedures, so that we can create a procedure and we pass values using parameters. And this has given us a range of things that we can actually do where we have a task we want to perform.
Yeah, and procedures have been useful for performing certain tasks for us, like you've said, but I want a way where I can create like a certain artifact that can calculate a value for us, like a meaningful value, and we can use that within our programs.
Yeah, well, this is a case where we can use functions. Functions are a way for us to encapsulate, so capture all of the steps that we need to perform in order to calculate a value. They're very, very similar to procedures, and the code looks very similar, but it has one major difference. A procedure does a task, and so it performs that task, whereas a function should be used to calculate a value.
Okay, well, I think what we've got there, I can perhaps apply that to my little program here. Because I've got all these different mathematical expressions in main, but they don't really belong there. I want to be able to put them, isolate them in their own artifact, and every time I call that, it just returns the value that I need it to.
Yeah, so well, what does the program actually do?
Okay, so this program is a body fat calculator. Okay?
That sounds good.
Yeah, I'm in touch with my weight, and just needed something to represent that. So.
Yep. All right, so at the moment, I can see you've declared a number of constants.
Yeah.
So this is something we should also talk about. So constants are a great way of making values more meaningful and values that are not going to change.
Yeah, exactly. And that's why I've got these here, because I need these two values to perform the mathematics required for me to calculate my body fat percentage.
Yeah. So the different constants, you can think about them just like variables, but the main difference is a constant's value doesn't change throughout the execution of the program. So, for example, in this, we're never going to change the ratio of converting kilograms into pounds.
Yeah, so that's exactly right. Basically, we've got the user; they need to input these values, their weight in kilograms and their waist measurement in centimeters. But the program that I've developed is based on a system that the US Navy came up with to calculate people's body fat percentage. So I need a meaningful way to be able to convert someone's weight in kilograms to pounds and centimeters to inches, and that's why I've got these constants, and they're more meaningful than just writing 2.205 anywhere in the code. I want to be able to see exactly what that value is. So in this instance, it's kilograms to pounds.
Yeah.
And the other one is centimeters to inches, which is 0.394.
Yep. Cool. All right, so I can also see down in main, we're reading in the values for the user's weight and waist measurement, and then I'm assuming these next bunch of code here is the code that calculates the body fat percentage.
Yeah, so that's the code that will calculate the body fat percentage, and it'll do it once, but I want to be able to do it over and over again in my program, because I don't want to have to remember this sequence of instructions every time I want to do this.
Yeah, because it's a lot of code you'd have to type in each time.
Yeah.
All right, so what we could do, so does this work for both males and females?
Well, good thing you bring that up. This is just for males. Okay. So that's a good idea. Perhaps I want something to be able to calculate body fat percentage for males and something else that works for females.
Yeah. Okay. All right. Well, what we could do is move all the calculation code up into our own function.
Okay.
And so that function, we would need to give it parameters. So what the two values the users enter is going to be their total body weight and their waist measurement.
Yeah, yep.
And everything else you can calculate off that. That's right?
That's exactly right. Yeah.
Yeah, so those two things can become our parameters.
Yep.
So that's sort of going back to the video on that we've talked about parameters. So this would enable you to pass in those two values into this function.
Yeah, and that's the only information the function will need to calculate that value for us.
That's right, and it can then create its own local variables in order to calculate all of the sort of the values you're using along the way to work out the final result of the function.
Yeah, okay. And this is just like a procedure. I can I can call this as many times as I want in my
Yeah.
program, but the
Yeah.
difference is this will calculate a value for me
Yeah.
and return it.
Yeah, so what we've got, if you have a look at the code here, we can see the return type.
Yep.
So this indicates that this function is going to return a double value.
Okay.
Whereas a procedure says that it returns nothing.
Yeah, yeah.
It just does stuff and then it finishes.
Yep.
A function performs the steps, so it still does. If you look at it, it looks just like a procedure.
Yeah, yeah.
The only difference is that at the end we return a value, and this here determines the type of value, and down the bottom here, this is how we indicate what value we want to actually return from the function.
Okay, and in this instance, the value that it returns is stored in result.
Yeah, that's correct. Yeah, and then the result is returned, and so that is the value that sort of comes back when the function finishes.
Cool. So down here in main now, I've got this variable called fat percentage, or fat percent rather, and I can just assign the value returned by our function male body fat percent to that variable.
Yeah, that's right. So we call this, what happens down here, we call that function, it comes up, executes those instructions, passing those two values across to the two parameters.
Yep.
And then at the end of the function, we get the result, and the result is returned. And so this function call down here effectively gets that value, or becomes that value, and then that value can be assigned into the fat percent. And we can print that out.
Yeah, that's really neat.
What's really cool now is you can also just call that function again. And so this time we could pass in some extra values. So say, 74.4 kilos with a 83.4 centimeter waist.
Yeah.
And then that function would calculate the male body fat percentage for that person, and that would be stored into fat percent.
Yeah.
And we can print that out. And so you notice that that's much easier than having to type in all of that.
We'll repeat it, yeah.
Yeah. And I think what you'll find even cooler, notice we're only really using the fat percent just to output the value.
Yeah.
What we could actually do, rather than storing the value in the variable and then using the variable, you can just use the result of the function inside another expression. So down here where we're printing out the value, we can just call the function, and whatever value is returned, we can just say, we'll just print that out. We multiply it by 100, etc.
Yeah.
And then print that value out. So you don't have to always store the values in variables if you don't need the variable for some other use.
So what you're saying is that will do the same thing as assigning that value to a variable and then printing that variable out.
Yeah. The only thing is at the end of this line here, you can't get back to that value.
Yeah.
You used it and it's gone.
Yep.
Whereas if I stored it in a variable, I could then just use the variable over and over again.
Cool.
So you have to think about that. If you only want to use it once, then you don't need to store it in a variable. Just use it wherever you want to use it. Otherwise, store it in a variable and then use it multiple times.
Yeah.
So one thing you'd want to avoid would be, say, if I wanted to, use the male body fat percent of the person with 82 kilograms, 101.4
Yeah.
centimeter waist, then if I call that function again, it has to go back up here and recalculate the value. So if I did
Yeah.
want to use it more than once, definitely save it in a variable.
Yep.
Only using it once, you can skip that step.
Cool.
All right, Ruben, did you want to run through how this works? Maybe we'll just go through the first calculation of the body fat percent in detail, and then the other ones will just sort of... The steps are the same, but we'll just skip over them a bit more quickly.
Sure. So the first thing that happens when the program is executed is we go down to main, and we've got these variable declarations here. The first two are weight and waist measurement, and they're doubles. And fat percent, which is also a double.
Yeah, so we've allocated space for 3 variables, all that can store whole real numbers.
Yeah.
Yeah.
Yeah. So the first thing that happens in the program is we assign a value to our weight variable, and we do that by calling read double.
So what do you think read double is?
Well, now that you've told me about functions, I'm almost certain that read double is in fact a function.
That's correct. So read double is just a function that somebody else has written.
Yeah.
In this case, us. And that function takes in one parameter, which is the prompt, the message we're going to show the user. It then reads whatever I type at the keyboard, and that value, when it comes back, is assigned to that variable.
Yeah.
So that we've been using functions already. This is just, now we can also create our own.
Yeah, cool. So in this instance, let's assign the value 90.2 to our weight variable.
Yep, so 90.2 comes back from the function.
Yep.
We store it in the weight.
Yep. Now, our next instruction is to assign a value to our waist measurement variable. So the same thing happens again.
So it's using the read double function.
Yep.
Let's assume the user returns or types in 86.5.
That'll be good. And that value is then returned by that function and stored in the waist measurement variable.
Yep, by the assignment statement.
Yep.
So now we get up to our magical part. Yeah.
This is it. So this is where we get to use the function that we've created. We're going to call male body fat percent, and we're going to pass those two values in from our variables weight and waist measurement as parameters.
Yeah, so weight will be passed up, and it will go into the total body weight parameter in the male body fat percent function.
Mm-hmm. And then waist measurement will also be passed up into the waist parameter in the male body fat percent function.
Yeah.
Okay.
Cool.
So that function's been called. We've got some variables here that are declared.
So it's going to appear on top on the stack. So
Yes.
that when this finishes, it knows where to go back to.
Yeah, that's correct.
Yep.
We've got these different variables here: factor 1, factor 2, lean body mass, body fat weight, and weight in pounds.
Yep.
We need all those different variables for our calculations.
Yep. So they're all allocated space.
Yep. Okay, so the first thing that we need to do is we're going to calculate total body weight multiplied by our constant value of kilograms to pounds.
Yeah, so this is going, when we use the constant, it's just like using a variable that's actually just going to be replaced with the value 2.205.
Yeah.
And so effectively what you're doing here is converting the user's weight in kilograms into pounds.
Yep.
So you can use that through the rest of the code there.
Yeah. And that expression is 90.2 multiplied by 2.205, which is equal to 198.891.
Cool. And that gets stored in our weight in pounds.
Yeah.
Cool.
Our next expression is we've got weight in pounds, so the value that we just calculated, we've got to multiply that by 1.082 plus 94.42.
So the result of that, 309.62,
Sounds pretty
which is stored in factor 1.
Yeah.
Now, in this case here, we do have two magic numbers, 1.082 and 94.42. These just come from the
that system.
US Navy's
Yeah.
formula. They don't get any reasoning or rationale, so
Yeah.
we can't really come up with meaningful names for those values. So you'd have to think about whether we could come up with something, but in this case, we'll just leave them as values.
Yeah. So that value gets assigned to factor 1.
So we calculate factor 2, same sort of way. Yep. So waist times this kind, we're converting it centimeters to inches.
Yeah.
And they've got their magical factor of, well, it is magical, isn't it? We have no bloody idea why it's 4.15, but that's what it is.
Yeah.
So we multiply by that by 4.15. So that gives us a total of
141.436.
Yep, which we store in factor 2.
Yeah.
So when we calculate the lean body mass, that ends up being
168.184.
Yep.
Yep.
And that gives us a total body fat of, what is that, 198.891 minus
168.184,
So-
which is 30.707.
Yeah, and that is stored in our body fat.
Yep. And now we're up to our body fat percentage result calculation,
Yep.
which
So-
is body fat weight divided by weight in pounds.
So 30.707 divided by 198.891.
Yep.
Which
Which
is-
is 0.1544.
Yeah, and that is stored in the
Result variable.
Yeah. So at the end of the function, what happens?
The function returns that value. It returns our result.
Yeah, so it returns the result.
Yep.
Which is 0.144. So what happens now?
0.1544.
Yeah, thank you.
That's okay.
So we come back down here to main now, and this function call here has now become the value 0.1544.
Yep.
So that's what we mean by return. We mean that the function ends, and where it was called from becomes that value.
Okay.
And so this is now 0.1544, and so we can then just store that.
In our fat percent variable.
Yeah, so when we print it out, we get 15.44%.
Yeah.
Seems quite reasonable.
It does. That's a healthy individual.
So we then call the function again, and this time those two, we just get literal values passed across. So 74.4 gets passed into total body weight, and 83.4 gets passed into waste.
Yeah.
And we then go through those same steps.
Yep.
And it calculates, so we calculate the weight in pounds, factor 1, factor 2, etc.
Yeah.
And at the end, we get our result, which is...
In this case, it's 0.1737
Yeah, and that gets stored.
into fat percent.
Yeah, so that's the result that's returned.
Yep.
Becomes that value, and we store that in that fat percent.
Yeah.
We can print that out. And the same thing happens down in the bottom here. So when we call the male body fat percent with 82 and 101.4, that function gets executed. It runs all of the steps. At the end, it returns the value, and then it's just like you typed 0.3128.
Yeah.
Yeah. So that value there, 31.28%, when we multiplied by 100, that is, would be printed out.
Cool. And that pretty much wraps up the execution of that program.
Yeah. So here are some other examples.
As I said before, we needed another function to calculate female body fat percent because that one that we just demonstrated was for males only.
And so this is that function. Takes in a few extra parameters, has a few extra steps, but the same sort of idea. You call the function, pass in the values, it does its magic, and it comes back with a result.
Yeah.
We've got another one here to calculate the area of a circle. So we're using another constant here. So we create a constant for pi.
Yeah.
And we would have pi multiplied by the radius. It's a lot simpler function.
Yeah.
But would make it easier if you had to calculate circle areas a number of times.
And the final example here is squaring a number. And basically, you pass it a number as a parameter, and it will square that number for you and return the result. So, if you passed in 2, it would return 4.
Yeah, and so these other ones are slightly simpler functions. All right, that's it for functions. Functions, just like procedures, but they're used to calculate a value. So this is really useful if you have a bunch of steps or some sort of calculation you need to perform and you want to get a result back, like a number. It doesn't have to be a number. It could be, we did doubles in this one. It could be returning a string, such as read string. Or integer, read integer, etc.
Yep. We've also got some videos on parameters and procedures, as well as variables.
Yeah, so if you haven't checked those ones out, go back and have a look at those ones now. They should sort of complement this one.
Yeah, and coming up, we're going to be introducing you to control flow, which gives you the ability to introduce much more dynamic behavior in your programs.
Yep. All right, that's it for functions. Hope you've enjoyed this, and we look forward to seeing you again soon.
Bye.
This has been a Swindon production. Swinburne University of Technology.
Hi, and welcome to Swinburne Codecasts. I'm Andrew Kane.
And I'm Ruben, and in this video we're going to be looking at creating your own functions.
So far, we've been able to create programs that use procedures as a list of tasks that sort of perform an action. We have variables that we can store values in. We also should have looked at how to pass values to procedures so that we can create a procedure and we pass values using parameters. And this has given us a range of things that we can actually do where we have a task we want to perform.
Yeah, and procedures have been useful for performing certain tasks for us, like you've said, but I want a way where I can create like a certain artifact that can calculate a value for us, like a meaningful value, and we can use that within our programs.
Yeah, well, this is a case where we can use functions. Functions are a way for us to encapsulate, so capture all of the steps that we need to perform in order to calculate a value. They're very, very similar to procedures, and the code looks very similar, but it has one major difference. A procedure does a task, and so it performs that task, whereas a function should be used to calculate a value.
Okay, well, I think what we've got there, I can perhaps apply that to my little program here. Because I've got all these different mathematical expressions in main, but they don't really belong there. I want to be able to put them, isolate them in their own artifact, and every time I call that, it just returns the value that I need it to.
Yeah, so what does the program actually do?
Okay, so this program is a body fat calculator. Okay?
That sounds good.
Yeah, I'm in touch with my weight and just needed something to represent that. So.
Yep. All right, so at the moment, I can see you've declared a number of constants.
Yeah.
So this is something we should also talk about. So constants are a great way of making values more meaningful and values that are not going to change.
Yeah, exactly. And that's why I've got these here, because I need these two values to perform the mathematics required for me to calculate my body fat percentage.
Yeah. So the different constants, you can think about them just like variables, but the main difference is a constant's value doesn't change throughout the execution of the program. So, for example, in this, we're never going to change the ratio of converting kilograms into pounds. Yeah,
so that's exactly right. Basically, we've got the user; they need to input these values, their weight in kilograms and their waist measurement in centimeters. But the program that I've developed is based on a system that the US Navy came up with to calculate people's body fat percentage. So I need a meaningful way to be able to convert someone's weight in kilograms to pounds and centimeters to inches, and that's why I've got these constants, and they're more meaningful than just writing 2.205 anywhere in the code. I want to be able to see exactly what that value is. So in this instance, it's kilograms to pounds.
Yeah.
And the other one is centimeters to inches, which is 0.394.
Yep. Cool. All right. So I can also see down in main, we're reading in the values for the user's weight and waist measurement, and then I'm assuming these next bunch of code here is the code that calculates the body fat percentage.
Yeah, so that's the code that will calculate the body fat percentage, and it'll do it once, but I want to be able to do it over and over again in my program, because I don't want to have to remember this sequence of instructions every time I want to do this.
Yeah, because it's a lot of code you'd have to type in each time.
Yeah.
All right, so what we could do, does this work for both males and females?
Well, good thing you bring that up. This is just for males. Okay. So that's a good idea. Perhaps I want something to be able to calculate body fat percentage for males and something else that works for females.
Yeah. Okay. All right. Well, what we could do is move all the calculation code up into our own function.
Okay.
And so that function, we would need to give it parameters. So what the two values the users enter is going to be their total body weight and their waist measurement.
Yeah, yep.
And everything else you can calculate off that. That's right?
That's exactly right. Yeah.
Yeah, so those two things can become our parameters.
Yep.
So that's sort of going back to the video that we've talked about parameters. So this would enable you to pass in those two values into this function.
Yeah, and that's the only information the function will need to calculate that value for us.
That's right, and it can then create its own local variables in order to calculate all of the sort of the values you're using along the way to work out the final result of the function.
Yeah, okay. And this is just like a procedure. I can I can call this as many times as I want in my
Yeah.
program, but the
Yeah.
difference is this will calculate a value for me
Yeah.
and return it.
Yeah, so what we've got, if you have a look at the code here, we can see the return type.
Yep.
So this indicates that this function is going to return a double value.
Okay.
Whereas a procedure says that it returns nothing.
Yeah, yeah.
It just does stuff and then it finishes.
Yep.
A function performs the steps, so it still does. I mean, if you look at it, it looks just like a procedure.
Yeah, yeah.
The only difference is that at the end we return a value, and this here determines the type of value, and down the bottom here, this is how we indicate what value we want to actually return from the function.
Okay, and in this instance, the value that it returns is stored in result.
Yeah, that's correct. Yeah, and then the result is returned, and so that is the value that sort of comes back when the function finishes.
Cool. So down here in main now, I've got this variable called fat percentage, or fat percent rather, and I can just assign the value returned by our function male body fat percent to that variable.
Yeah, that's right. So we call this, what happens down here, we call that function, it comes up, executes those instructions, passing those two values across to the two parameters.
Yep.
And then at the end of the function, we get the result, and the result is returned. And so this function call down here effectively gets that value, or becomes that value, and then that value can be assigned into the fat percent. We can print that out.
Yeah, that's really neat.
And what's really cool now is you can also just call that function again. And so this time we could pass in some extra values. So say, 74.4 kilos with a 83.4 centimeter waist.
Yeah.
And then that function would calculate the male body fat percentage for that person, and that would be stored into fat percent.
Yeah.
And we can print that out. And so you notice that that's much easier than having to type in all of that.
We'll repeat it, yeah.
Yeah. And I think what you'll find even cooler, notice we're only really using the fat percent just to output the value.
Yeah.
What we could actually do, rather than storing the value in the variable and then using the variable, you can just use the result of the function inside another expression. So down here where we're printing out the value, we can just call the function, and whatever value is returned, we can just say, we'll just print that out. We multiply it by 100, etc.
Yeah.
And then print that value out. So you don't have to always store the values in variables if you don't need the variable for some other use.
So what you're saying is that will do the same thing as assigning that value to a variable and then printing that variable out.
Yeah. The only thing is at the end of this line here, you can't get back to that value.
Yeah.
You used it and it's gone.
Yep.
Whereas if I stored it in a variable, I could then just use the variable over and over again.
Cool.
So you have to think about that. If you only want to use it once, then you don't need to store it in a variable. Just use it wherever you want to use it. Otherwise, store it in a variable and then use it multiple times.
Yeah.
So one thing you'd want to avoid would be, say, if I wanted to, use the male body fat percent of the person with 82 kilograms, 101.4
Yeah.
centimeter waist, then if I call that function again, it has to go back up here and recalculate the value. So if I did
Yeah.
want to use it more than once, definitely save it in a variable.
Yep.
Only using it once, you can skip that step.
Cool.
All right, Ruben, did you want to run through how this works? Maybe we'll just go through the first calculation of the body fat percent in detail, and then the other ones will just sort of... The steps are the same, but we'll just skip over them a bit more quickly.
Sure. So the first thing that happens when the program is executed is we go down to main, and we've got these variable declarations here. The first two are weight and waist measurement, and they're doubles. And fat percent, which is also a double.
Yeah, so we've allocated space for 3 variables, all that can store real numbers.
Yeah.
Yeah.
Yeah. So the first thing that happens in the program is we assign a value to our weight variable, and we do that by calling read double.
So what do you think read double is?
Well, now that you've told me about functions, I'm almost certain that read double is in fact a function.
That's correct. So read double is just a function that somebody else has written.
Yeah.
In this case, us. And that function takes in one parameter, which is the prompt, the message we're going to show the user. It then reads whatever I type at the keyboard, and that value, when it comes back, is assigned to that variable.
Yeah.
So that we've been using functions already. This is just, now we can also create our own.
Yeah, cool. So in this instance, let's assign the value 90.2 to our weight variable.
Yep, so 90.2 comes back from the function.
Yep.
We store it in the weight.
Yep. Now, our next instruction is to assign a value to our waist measurement variable. So the same thing happens again.
So it's using the read double function.
Yep.
Let's assume the user returns or types in 86.5.
That'll be good. And that value is then returned by that function and stored in the waist measurement variable.
Yep, by the assignment statement.
Yep.
So now we get up to our magical part. Yeah.
This is it. So this is where we get to use the function that we've created. We're going to call male body fat %, and we're going to pass those two values in from our variables weight and waist measurement as parameters.
Yeah, so weight will be passed up, and it will go into the total body weight
Yep.
parameter in the male body fat % function.
And then waist measurement will also be passed up into the waist parameter in the male body fat % function.
Yeah,
Okay,
cool.
So that function's been called. We've got some variables here that are
So
declared.
yeah, so it's going to appear on top on the stack, so
Yes.
that when this finishes, it knows where to go back to.
Yeah, that's correct.
Yep.
We've got these different variables here: factor 1, factor 2, lean body mass, body fat weight, and weight in pounds.
Yep.
We need all those different variables for our calculations.
Yep. So they're all allocated space.
Yep. Okay, so the first thing that we need to do is we're going to calculate total body weight multiplied by our constant value of kilograms to pounds.
Yeah. So this when we use the constant, it's just like using a variable that's actually just going to be replaced with the value 2.205.
Yeah.
And so effectively what you're doing here is converting the user's weight in kilograms into pounds.
Yep.
So you can use that through the rest of the code there.
Yeah. And that expression is 90.2 multiplied by 2.205, which is equal to 198.891.
Cool. And that gets stored in our weight in pounds.
Yeah.
Cool.
Our next expression is we've got weight in pounds, so the value that we just calculated. We've got to multiply that by 1.082 plus 94.42.
So the result of that, 309.62,
Sounds pretty
which is stored in factor 1.
Yeah.
Now, in this case here, we do have two magic numbers, 1.082 and 94.42. These just come from the
that system.
US Navy's
Yeah.
formula. They don't get any reasoning or rationale, so we
Yeah.
can't really come up with meaningful names for those values. So you'd have to think about whether we could come up with something, but in this case, we'll just leave them as values.
Yeah. So that value gets assigned to factor 1.
So we calculate factor 2, same sort of way. So waist times this kind, we're converting it centimeters to inches.
Yeah.
And they've got their magical factor of, well, it is magical, isn't it? We have no bloody idea why it's 4.15, but that's what it is.
Yeah.
So we multiply that by 4.15. So that gives us a total of
141.436.
Yep, which we store in factor 2.
Yeah.
So when we calculate the lean body mass, that ends up being
168.184.
Yep.
Yep.
And that gives us a total body fat of, what is that, 198.891 minus
168.184,
So-
which is 30.707.
yeah, and that is stored in our body fat.
Yep. And now we're up to our body fat percentage result calculation,
Yep.
which
So-
is body fat weight divided by weight in pounds.
So 30.707 divided by 198.891.
Yep.
Which
Which
is-
is 0.1544.
Yeah, and that is stored in the
Result variable.
Yeah. So at the end of the function, what happens?
The function returns that value. It returns our result.
Yeah, so it returns the result.
Yep.
Which is 0.144. So what happens now?
0.1544.
Yeah, thank you.
That's okay.
So we come back down here to main now, and this function call here has now become the value 0.1544.
Yep.
So that's what we mean by return. We mean that the function ends, and where it was called from becomes that value.
Okay.
And so this is now 0.1544, and so we can then just store that.
In our fat percent variable.
Yeah. So when we print it out, we get 15.44%.
Yeah.
Seems quite reasonable.
It does. That's a healthy individual.
So we then call the function again, and this time those two, we just get literal values passed across. So
Yeah.
74.4 gets passed into total body weight, and 83.4 gets passed into waste.
Yeah.
And we then go through those same steps.
Yep.
And it calculates, so we calculate the weight in pounds, factor 1, factor 2, etc.
Yeah.
And at the end, we get our result, which is,
In this case, it's 0.1737
yeah, and that gets stored.
into fat percent.
Yeah, so that's the result that's returned,
Yep.
becomes that value, and we store that in that fat percent.
Yeah.
We can print that out. And the same thing happens down in the bottom here. So when we call the male body fat percent with 82 and 101.4,
Yeah.
that function gets executed. It runs all of the steps. At the end, it returns the value, and then it's just like you typed 0.3128.
Yeah.
Yeah. So that value there, 31.28%, when we multiplied by 100, that is,
Yeah.
would be printed out.
Cool. And that pretty much wraps up the execution of that program.
Yeah. So here are some other examples.
As I said before, we needed another function to calculate female body fat percent because that one that we just demonstrated was for males only.
And so this is that function. Takes in a few extra parameters, has a few extra steps, but the same sort of idea. You
Yeah.
call the function, pass in the values, it does its magic,
Yep.
and it comes back with a result.
Yeah.
Yeah. We've got another one here to calculate the area of a circle. So we're using another constant here. So we create a constant for pi.
Yeah.
And we would have pi multiplied by the radius. It's a lot simpler function.
Yeah.
But would make it easier if you had to calculate circle areas
Yeah.
a number of times.
And the final example here is squaring a number. And basically, you pass it a number as a parameter, and it will square that number for you and return the result. So, if you passed in 2, it would return 4.
Yeah, and so these other ones are slightly simpler functions. All right, that's it for functions. Functions, just like procedures, but they're used to calculate a value. So this is really useful if you have a bunch of steps or some sort of calculation you need to perform and you want to get a result back, like a number. It doesn't have to be a number. It could be, we did doubles in this one. It could be returning a string, such as read string.
Yeah.
Or integer, read integer, etc.
Yep. We've also got some videos on parameters and procedures as well as variables.
Yeah, so if you haven't checked those ones out, go back and have a look at those ones now. They should sort of complement this one.
Yeah, and coming up, we're going to be introducing you to control flow, which gives you the ability to introduce much more dynamic behavior in your programs.
Yeah. All right, that's it for functions. Hope you've enjoyed this, and we look forward to seeing you again soon.
Bye.
This has been a Swindon production. Swinburne University of Technology.
Hi, welcome to this podcast on hand execution. So what we're going to have a look at in this podcast is first, well, what is hand execution? And then uses of hand execution. So why am I asking you to do this? And performing hand execution. So the process by which I want you to be able to perform hand execution as part of the unit. And it's important that you follow the process that we've specified. So what is hand execution? When we're programming, we write code for the computer to execute. With hand execution, what we actually do is execute that code ourselves using paper and pencil. It's a fairly simple process, but it's really important to help us understand what the code we are writing does. So as I said, we write code mostly for the computer to execute. That's the purpose of our code. But what we want to do is really understand what that code does. What does that code tell the computer to do? When we understand how the different statements get the computer to do different things, you can then better understand your code, and you'll be able to create code that will do whatever you want to do because you'll understand what each of the different actions gets the computer to do. So with hand execution, what we're doing is performing the actions that we have in our code one step after the other. Now, the great thing is computers are unintelligent. So hand execution isn't super tricky. It's doing what a computer does. A mechanical process do exactly what the code says to do. And so the one thing you have to really understand is what are the actions that the code means. So when I say x colon equals 10, what does that do? What does that mean? So we have to understand how the computer interprets those, or how the compiler gets the computer to do those actions. What is it actually doing? You then perform the action one after the other. So each action you just perform in sequence, the same as the computer would do. And the key here is to understand, what are these actions getting the computer to do? So when we write a certain piece of code, what does the computer actually do when it runs that piece of code? And that's what we're really after here, that understanding. Now, when we go through hand execution, some of the things you might want to do as you're going through it, it is a mechanical process to execute the code, but then we can try to understand the code more deeply. Now, what was the purpose of this code? This code was written by a programmer. They had some purpose. They wrote it for some reason, hopefully. So they wrote the code for some, what does it do? Why are these set of instructions provided? What does this sequence mean? What does it do? And we can analyze the code that we're reading to try to work out how it achieves goals. So if I know what the task is, it's supposed to be doing this, but I don't understand how it's doing that, then when I read through the code and try to work out what it's doing, I'm analyzing that code in order to work out how it achieves the goals. So I know what the goal is. How do we actually achieve that with this piece of code? So in general, the uses for hand execution firstly, to help you understand what are we telling the computer to do. When I say this piece of code, what does it mean? What does it get the computer to do? It also gives us a way, or gives you a way, to demonstrate that you do understand what the computer does. Because part of the assessment for this unit is you need to demonstrate your understanding of these different actions that you're going to get the computer to do, the different statements in the programming languages. And so by hand executing something, you're able to show, I can read this code and I can tell you what the computer will do. Okay? So it's important with this hand execution process, you're trying to demonstrate the process, not just the final answer. All right? We don't want an answer out of this. This is a process demonstration. Okay. Another thing that we can do with hand execution is locate errors. Sometimes, quite frequently, I think, the code that we write has small mistakes in it, obviously unintentional, and we write it thinking that it's going to do what we want it to do, but when we run it, the computer doesn't do what we want. It's very frustrating. But what we need to do then is look at our code. The computer's done exactly what we told it to do. Yeah, so the problem, it's our problem. We made a mistake. We need to think about, well, what does the code actually do? And so hand executing gives you a way of going through the code and saying, well, what this is, I know I wanted it to do this, but it's doing something else. Why is it doing that something else? And you can look at your code and work out where your errors are. Okay, so now let's get to the process of hand execution. Okay, so here what we have is some code. And that code is the code to draw a house. And it's taking some parameters. We've got some local variables here. And we've got some actions. And what we want to do is work out what these actions do. What happens when we execute this code on the computer. Now down the bottom here, I have my call. So we're going to execute the call to draw house, which takes parameters or takes values 50, 75, 100, and 200. So what happens when this code is executed for that procedure call? So over here, what I could do is, let's just write down that procedure call so we don't forget. So it's draw house. Sorry about my writing. 50, 75, 100, 200. Okay, so that's our procedure call. Okay, you have to bear with my drawing. So what we want to do now is execute this code. So this call has happened, and the computer is now going to execute this procedure. Now, if we look at that, oh, that's a lot of code. How are we going to understand all of that? Well, remember, the computer doesn't do that. It's not looking at all of this and trying to work out some greater meaning for what draw house means. It's just going to execute this. So let me just hide away all the stuff we don't want to see. Okay. When we're doing this, just focus one line at a time, okay? And sometimes less than a line. But at the moment, one line at a time. So here's our one line, draw house, X, Y, width, height. That is the piece of code that we're starting here. This is going to execute this draw house procedure. And we have these parameters here. Now, parameters are variables. So this piece of paper here, or this drawing here, you should do this on a piece of paper with a pencil. Yeah, no need to make it fancier than it needs to be. What we can do is this can represent memory. And inside this memory, we can allocate data for our variables. So X, Y, width, and height become variables. So I can declare a variable X, and it's allocated a piece of memory, which I'll draw a box to represent that piece of memory. So here is X's memory, that bit there. Whenever I refer to X, I mean whatever is written in that box. We can do the same with Y and with width and height. There we go. Excellent. So when we execute this, the first thing that's going to happen is the computer needs to allocate space for all of the parameters. So each of these parameters becomes a variable inside which we can store a value. And these values here, the 50, 75, 100, 200, are assigned to these variables when this procedure starts. So the value of X will be 50. The value of Y will be 75. The value of width will be 100. The value of height will be 200. Okay, so there's our parameters. Let's switch back to our code. So we've finished executing that line of code. Let's move down. All right. Oh, we can look at these ones all together. The next thing that we have in our code is var. So this is a variable declaration section. And in here, we have a number of different kinds of variables. So we can have roof height, and we create a variable for that. There it is. We need wall width. We create a space for that. We can have wall X. Wall Y. right side, maybe up here. And middle. Okay, so this has, when this code executes, the computer allocates space for a number of different variables. Now, at this point, what we'll do is leave these variables empty because we don't know what their value is. If you ask me what is the roof height, well, I don't know. It's something, but we haven't yet given it a value. There will be a value here in the computer, but it's we can consider it to be a random value because we haven't given it a value. It's just whatever happened to be in memory the last time this bit of memory was used. Okay? So it's important that you assign a value to your variables before you use them. All right, so let's move on. What's next? Now we have our begin. All right, we're getting a bit. We do just want to focus on one line of code, so you can also forget all of that. There we go. Look at that. Just one line of code. Begin. All right, that just means start. So we can start. There's the next one. All right. So what we have now is a statement. What does this statement do? So this is an assignment statement, and we know that because of this colon equals symbol here. So an assignment statement does two things. So it gets the computer to do two things. The first thing the computer does is evaluate the expression on the right-hand side. So that's this expression here. And whatever the result of that expression is assigned into this variable, the roof height in this case. All right, so let's evaluate the expression. My expression is round, open brackets, 0.33 multiplied by height, close bracket. Okay, what does that mean? Well, round is a function, and this function takes a floating point value, like a single or a double value, and it returns a whole number, an integer. Okay, and it's going to round that off. So 9.9 would round to 10, whereas 6.2 would round down, so it would round to 6. So it rounds up above 0.5, etc. All right, so what's my calculation do? 0.33 multiplied by height. Well, what is height? So we don't need to remember that. We just look over here. It tells us height is 200. So 0.33 times 200 will be 66. And it'll be 66.0 because this is a single, a floating point value. But what we'll do is round that, so it will become 66. And so the value here is 66. And that is assigned to roof height. So roof height is assigned the value 66. Okay. That's that statement done. We can move down to the next statement. All right, so the next statement, similar thing. 0.8 multiplied by width is going to be rounded and assigned to the wall width. So remember, it's an assignment statement. So first thing, evaluate the right-hand side. To call the round function, I need to work out its parameter value. So this value here has to be calculated first. That will then be passed into the round function. It will round it off for us, and the result that we'll get will be the integer value. So 0.8 times width will be 80, 80.0 in this case, and that 80.0 will be rounded to 80, and we can assign 80 to the wall width. So wall width over here becomes 80. All right, that's that one done. And notice this is all we do with hand execution. Usually you don't have these boxes to help you, but just focus on one line at a time. Assignment statement, height minus roof height. All right, so what's height? Well, height is 200. What is roof height? Roof height is 66. So what is 200 minus 66? All right, and we assign that. So 200 minus 66 is 134. 134 we are going to put into wall height. Did I miss that one when I wrote it down? I did, didn't I? Okay, that's okay. We can adjust. In my rush to get through this, I forgot to create the wall height variable. So let's just add that in quickly. Nobody will know. Wall height. And 134. Okay, so there's our wall height. And we can continue on to execute this . We can continue to execute each of the assignment statements one after the other until we get to the end. So that's the hand execution complete, and what we can work out from this is the shape of the house. So each of the different variables represents different values related to that house. So if we go through that, we can work out that the house shape should be something like this, based on the different values, the wall X being the offset from the edge of the triangle for the wall, the width and the height of the rectangle being the wall width and the wall height, and then we have the roof height as well. Okay, so that's the process of hand execution. I hope you enjoyed it or found it useful, and I'll talk to you later. Bye.
This has been a Swinburne production. Swinburne University of Technology.
Hi and welcome to Swinburne Codecasts. I'm Andrew Kane.
And I'm Jake, and in this video we'll be looking at control flow.
So far, our programs have been a sequence of instructions that always perform the same task.
Yeah, and that's been really cool so far. But wouldn't it be great if we could alter the sequence that our instructions run?
Yeah, we can use control flow statements to do that. That allows us to provide points in the code where we make a decision and we run some code or don't run the code, and allows us to have loops where we repeat code a number of times.
Yeah, so I'm writing this circle moving program, but I'm having a lot of troubles getting the circle to even move. So let's have a look through Swing Game.
So what we have here is a basic Swing Game program. It shows a window, clears the screen, refreshes and delays for 2 seconds.
Cool, but I don't really want it to run for 2 seconds. I want it to run until my user exits my program.
All right, and we can do that by using a loop. So rather than having the program just run that sequence of instructions and delay, we can tell it that we want to repeat these instructions until the user has closed the window.
Cool, that sounds perfect.
Now, one thing that we have introduced here is a call to process events.
Okay.
So process events is checking all of the things that have happened to your window in this case, since the last time that process events was called.
So this is kind of detecting the exit click.
Yeah, and also check other things like key presses, mouse moves, networking code, messages that are sent over the network, that sort of thing.
Cool.
And this kind of structure is sort of central to all windowed applications. Right. So anything you've used on Mac, Windows, your phones, etc., all have this idea of an event loop, and they all work the same way. Get the event, do something with that event.
Perfect. So when I've run this program, I can see now it's just staying there until I click the exit.
So let's count. Yeah, 1, 2. See, it's way more than 2 seconds. It's still there.
Cool.
Yeah. Perfect. So now when we close the window,
it exits.
It exits.
Cool.
Yeah.
But I'm still not drawing my circle, so can we get that circle in there now?
Yeah, so what we can do is we can add a variable for x, because you
Okay.
want to move the circle
Yep,
around.
exactly.
You probably have one for y as well, but we'll leave that for other
Yeah,
people to
let's
play
just
with.
demonstrate it with X.
Yeah. And we can then add code into that repeat loop between where we clear the screen and where we refresh the screen that draws the circle. So each time through the loop, we actually clear the whole screen, get rid of everything,
Yep.
redraw the circle, and then show the user what we've done.
Cool. So now that my circle's been drawn, can we maybe move it to see if that will work with my X variable?
Yeah, so why don't we, each time through the loop, we can subtract 1 from the value of
So
x.
that should move it off the screen towards the left.
Yes, so
Cool.
we'll move it towards the left and then off the screen.
Yeah, so we put in this X equals X minus 1, and so every time the loop runs, it subtracts 1 from X, and
Yep.
that moves the circle off the screen.
That's correct.
Cool.
And so when we run that, we can see the circle disappears.
Perfect. But what I really want to do is only move off the screen or towards off the screen when my left key is being pressed.
Okay, so we can use a branching statement for this. And so
Okay.
the way we can think about that is rather than when the key is held down, we say if the key is held down.
Okay.
Because remember, the computer is executing the instructions one at a time.
Yep.
And so it's only at that point when it checks if the key is held down.
Right. And if it is held down, we subtract 1 from X, which has the effect of moving our circle.
That's correct.
Cool.
Whereas if it's not held down, then that code is actually skipped, and so the value of x remains the same. And so the position of the circle would remain constant.
So this is one of those branches of code you were talking about earlier.
That's correct.
We're only doing the subtraction at a certain time.
Yeah, if this condition
if
is met.
the button is down.
We can also add the same code in to move it to the right.
Yep.
In this case, we'll check if the right arrow is held down, and we can add 1 to the value of x, and that will push it off to the screen to the right-hand side.
So now when we run this, we can see holding left moves it left.
Yep, so
holding
if I hold
right,
down left,
yep,
moves left.
Right, right.
Yep.
What about both?
So if we hold down both, I think that's actually quite cool. So if we hold down both, look,
It's just not moving.
but that's perfect. What it's actually doing is moving it to the left 1 pixel,
Yep.
and then we move it to the right 1 pixel.
But we only draw the circle at the end of those instructions. So
That's right.
it doesn't appear to move.
That's correct.
But it has moved.
Correct. It moved left and right.
But we just drew it at the end.
That's correct.
Perfect.
Okay, that's the end of this video on control flow. We've looked at the idea of using control flow to repeat code using instructions.
Yep.
And there's actually 2 different statements for that. One that checks after the loop, which is the one we were looking at here, and one that checks before, which is the while loop.
Cool.
And we have also got branches. So branches may let you make a decision and either choose to run code or not to run that code. We've looked at using the if statement for that. There's also a case statement version.
Yeah, and we actually have individual videos on each of those topics. So if, case, repeat,
And
and
looping,
while.
yeah.
Yeah, we
Yeah.
have videos to, you can guys go watch some more details on those topics.
Yeah. Hope you've enjoyed this video, and we look forward to seeing you again soon.
Bye.
Bye.
This has been a Swinburne production. Swinburne University of Technology.
Hi, and welcome to Swinburne Codecasts. I'm Andrew Kane.
And I'm Ruben, and in this video we're going to be looking at if statements.
So far, our programs have only run a sequence of instructions, and it's always the same sequence with one output.
And that sounds like a real limitation. So if only there was a way that we were able to respond to different conditions in our code.
Well, the great thing is we can use if statements to alter the sequence of the instructions in our program and thereby respond to conditions.
And really, that sounds quite cool. And I've got this little program here, and basically it asks the user for their age, and it's supposed to determine whether or not they're allowed into a nightclub. But at the moment, this is just a sequence of instructions that always results in kicking the user out.
Well, this sounds like a perfect case where we can use an if statement. So what we have there where we print out the message that they're not allowed to dance, we can put that into an if statement, and we can say only run that code if the age is less than a certain minimum age. And so when the computer gets up to that instruction, it will check if the age is less than a minimum age. And if it is, it will then run those instructions. Otherwise, it just jumps over them and skips them completely.
Okay, that's really cool. So we're going to kick the people out who are younger than the minimum age, but I want to be able to display a message for those who are old enough to get into the club.
Well, this is a case where we can use the else part of an if statement. So the if statement actually has two parts. We have the if part. So if this condition is true, run this set of code. And we can have more than one instruction there. We've only got one in this case, but we could have more than one. And we then have an else branch, which is run when that was false. So if this is true, run these instructions, else run these other instructions. So here, if the age is less than the minimum age, we say, go away, you're too young, come back in a few years. Otherwise, else, we run these other instructions.
Nice.
How does that sound?
Yeah, sounds sounds like it solves the problem that I had in the first place.
Cool. So Ruben, do you want to talk through how this works?
Yeah, sure. Okay, so when we first start the program, we've got to store the constant somewhere.
So that's loaded up into memory, yep.
It is, yeah. And what we do is we assign the value 18 because that's our minimum age. So we assign the value 18 to our constant minimum age. Then there's a call to the program's main, alrighty? And we've got a variable called age. So we allocate some memory for that variable.
And so that's where the users, when they enter their age, that's where we're going to store their
Yeah,
age.
exactly.
Yeah.
Yep. So let's, for example, just for case of stepping through this, let's say the user inputs 15, alrighty? So age is now assigned the value of 15. And we look at the if statement, we've got the condition, if age is less than minimum age. So is 15 less than 18?
Well, that's true. Last time I checked.
Yeah, exactly. So this section of code would get executed. Whereas if we go back and we assign the age variable a value, say 19, then we get to the if statement and we evaluate condition. Is age less than minimum age? Well, in this case, 19 is greater than 18. So we skip that bit and we go straight down to this section of code.
Yeah, so it will actually print out our dance message.
Yeah.
Yeah, that's it. Okay, here are some extra examples that we've written up. This first one uses the result of a function. So here we're checking if a key was typed on the keyboard. So if the user hit the spacebar key, we're going to play a sound. Now, one thing to notice with this one is that we're not actually saying if key typed equals true. This is a Boolean function, so it tells us true or false to start off with. So we don't need to actually say if key typed space equals true. We can just say if key typed space play sound. So I think it reads quite nicely.
Yeah, and you could use that in a game environment to determine whether or not a player wants to shoot a bullet or something.
Yeah, that's right. Yeah.
And the second example we've got, applies to a business domain where you're selling items. And it reads like, if stock is greater than 5 and at the same time stock is less than 10, then, we want to inform the user that their stock levels are running low.
Yeah, so this would work. So this would be a case of, for example, if we had 7 stock items. So if 7 is larger than 5, that is true, and 7 is less than 10, so that would be true for that case. Whereas it would be false if we had something like, what?
11?
11? Yeah, so 11 is larger than 5, though.
Yeah, but it's not less than 10.
Ah, cool. So that's why we use and. So that means that it's only going to work when both of the conditions are true. They both have to be true because we're using and. Yeah, that's cool. Okay, so that's the end of this video on if statements. So if statements help us turn what used to be just a sequence of instructions into something where we can have decisions and only execute code under certain conditions. If this is true, run this piece of code. Otherwise, run this piece of code. You should also consider checking out our other control flow videos. So have a look at the control flow videos on the case statement. But then there's also the looping statements.
Yeah, we've got some videos on while and repeat loops.
So I hope you enjoy those, and we'll look forward to seeing you soon.
This has been a Swindon production. Swinburne University of Technology.
Hi, and welcome to Swinburne Codecasts. I'm Andrew Kane.
And I'm Ruben, and in this video we're going to be looking at looping.
So far, our code has run each of the instructions in sequence. So one instruction following the next.
Yeah, which is really cool. But what if I want a way to be able to repeat code over and over again?
Well, for that, what we can actually use are looping instructions in our programs. So looping instructions are instructions that tell the computer to run a certain block of code once or more than once.
Righto. Well, I think we could possibly implement looping into this little program that I've got here. Basically, I want the user to tell us what their name is, and I want to be able to tell them that they're awesome repetitively. And as you can see here, I've actually written out awesome.
How many times are you printing out there?
I think I've got
1, 2,
10,
3, 4, 5,
maybe
6, 7,
11.
8, 9, 10. 10 times.
Yeah, so...
Is that enough?
Well, I mean, maybe I want to be told...
Anyway, yeah, 10 times at the moment. Yeah, that's cool.
Yeah, so is there a way that we can implement some kind of looping structure in this to, sort of save on the overhead?
Yeah, that's right. So rather than having this one instruction repeated 10 times ourselves, we can use a while loop to actually repeat that code for us. We only then need it once, but we do need a little bit of extra code to go around that. So what we've done here is declare a loop count integer variable. So this is somewhere where we can store a number. The reason we need that is because we have to be able to tell the loop when to stop. And so if we want it to do it a number of times, the way we could do that is keep a count of how many times we've done that and repeat, in this case, while that count is less than 10. Yeah. So we then assign before the loop count to the value 0. And while the loop count is less than 10, so 0 is less than 10. Yes?
Well, yeah.
Good. We then write out awesome. We add 1 to the loop count, so it would now be 1. And we go back again. And at the end of the while loop here, it jumps back to the start and it reevaluates that condition. So loop count would now be 1. 1 is still less than 10. Yeah. So it would print out awesome again. It would then add 1 to the loop count, so it would be 2.
Why do we need to keep adding 1 to loop count?
Well, if we didn't add 1 to loop count, it would always be 0, and 0 would always be less than 10.
So we would end up with an infinite loop.
An infinitely awesome name.
Yeah.
And it would never actually... the program would never finish telling us how awesome that name was. Yeah.
Sweet. So what actually happens when our loop count is, not less than 10?
Okay, so in this case, we're going to loop through. Once we get to loop count 10, so it was 9, 9 plus 1 is 10, we store 10 back in loop count. It goes back around and it checks while loop count is less than 10, so 10 is not less than 10, and so it jumps over those instructions inside the loop and continues on from the next instruction.
Okay, cool. And then the
so it'll print out the name. Yeah, so in this case, it would print out name is an, followed by 10 awesomes, and then name.
Nice.
Cool. Okay, now here's a new version where we pass across the number of times that we want the name repeated. So rather than having that as a fixed 10 times, here we're going to ask the user how many times they want it repeated, and we pass that in as a parameter. So Ruben, do you want to just quickly walk us through how this works?
Yeah, sure. So as you can see in main, we've got 2 variables that are declared. The first is called name. Okay, so that allocates space for us so that the user
For a string,
can, Yep. So the user can store their name.
Yep.
And our second variable is called count, and it's an integer. And we're going to store how many times the user wants to be told that their name's awesome within that variable. Okay, so the first thing that we do is we assign a value to name. So let's say the user's name is Fred,
so
for example.
we execute the read string function. Just as a reminder, the read string function asks the user what they want to, in this case, what is your name? They type something in, that string gets returned. We can store that string inside the name. So what are we going to have this time?
We can do Fred.
Fred,
I guess.
yeah, that's nice and easy to type.
And we're using read integer, okay, to assign the value to our variable count. So we've got read integer there. We're asking the user how many times they want to be told that their name is awesome.
So what's a 56,421
I think that's a little bit excessive. I think we can.
It would
probably-
work though, yeah.
It would definitely.
Okay,
Yeah,
cool.
yep.
Cool. Oh,
But-
okay, well, let's just start with 3.
Just for the sake of the. Yep, let's stick with 3. Okay, so we've got our name, Fred.
Yeah,
the
so
number
type
of
3.
times-
3 gets stored into count.
It does.
Yep, cool.
Okay. And then we've got our call to our procedure print awesome name. And you'll notice that we're passing that procedure 2 parameters.
Name and count.
Yeah.
So name gets copied into name. Is that the same name variable in print awesome name as in main?
That is not. No.
Ah, cool.
Okay. So the parameter has a unique name.
Yeah, a unique variable.
Yeah.
Yeah. So inside this print awesome name, that name parameter is its own variable, and here we're just copying the value from main's variable into print awesome names variable. And it's the same for count. So times inside print awesome name is a separate variable, and we copy the value of count into the variable times.
Yeah.
They only exist inside print awesome name.
Yep.
Anyway, sorry, keep going.
No, that's fine. And as you'll notice in print awesome name, we've got a variable declaration called loop count, and that is an integer.
And that only exists inside print awesome name as well.
Yeah, that's correct. Yep. And then we start the procedures block. Okay.
So we print out the name.
Yeah, and the name is Fred. We assign the value of 0 to our variable loop count.
So we put 0 into the loop count variable.
Yep.
Yep.
And then we get to our loop. Okay. So the expression for the loop is while or well.
Yeah, while.
Yeah,
that's
loop
good.
count is less than times and
So what's loop count at the moment?
0.
0. So is 0 less than times? What's times?
Times is 3 and 0 is less than 3.
Yep.
Okay, so we want to print out awesome to the terminal. And then we want to increment our loop count by 1.
So loop count is now 1.
Yep.
Yep.
The loop finishes and we go back to the top and we reevaluate that expression.
So is loop count less than times? So loop count is
1,
yep, and times is
3,
so 1 is less than 3. Yes.
most certainly. Okay.
Yep.
So we execute those instructions again. We increment loop count by 1, and then
So loop count's now 2.
yep. And we go back up to the top of our loop and we
Yeah.
evaluate that expression. So 2
Yep.
is less than 3.
Yep.
We execute our loop once more. We increment loop count by 1, so that is now 3.
Seems quite repetitive, this, doesn't it?
Well, yes, repetition.
Amazing. All right. Sorry.
So now we go back to our expression, and loop count is 3.
Is 3 less than 3?
No, 3 is 3. It is not less than 3. Okay, so that is where
Yep. Cool.
that's where our loop finishes.
Yeah,
all right?
and so we
we
come
skip
down-
over that, yeah. And we get to our final little printed message, which is just simply name. So in this
right on
case,
name.
we've got Fred is an awesome name. Awesome 3 times.
Yeah, cool. And then that's the end of print awesome name. So that procedure ends. And when that procedure ends, notice that the variables associated with that procedure lose scope. So they go out of memory, basically. We can think about it that way.
Cool.
They disappear. We come back to main and the program ends. But let's just try it one more time. So if we run this again, we'll do the same name. So we'll do Fred. But this time if I store 0 as the count. So I want 0 as the count. We call print awesome name. Fred gets copied across and 0 gets copied across into times. We get our loop count variable. Name is an gets printed out. We assign 0 to loop count. And then we do our first test while loop count is less than times. So what's the value of your loop count?
0.
And times is,
Also 0.
and now, as you said before, 0 is 0 in this case. So 0 is not less than 0. So it doesn't print awesome out at all.
So we get left with Fred is an name.
Not radically fantastic, but it'll do. Yeah. But that's correct. So this is one feature of the while loop. So the while loop is what we call a pre-test loop. So it tests the condition before, the actual body. And so in this case, we can run instructions 0 or many times. So we've seen how it ran 3 times. It could have ran 56,000 times. It just would have taken Ruben a bit longer to explain. But it doesn't matter how many times. It could be 0 or more times,
Yep.
depending on, in this case, the value of the times variable. Now, there is one other kind of loop, and that loop is a post-test loop. So the post-test loop, rather than checking the condition before the body, checks the condition at the end. So here is an example of a post-test loop. Now notice at the start, we have a marker for where the start of the loop is. We then have the list of instructions inside the loop, and we can loop, in this case, until a condition is true. And this will run the body of the loop one or many times because it has to get through the conditions before it gets to through the body of the loop before it can get to the test. So that's the difference between the two different kinds of loops. Okay, here are some additional examples. This first example is a validation loop. So it makes certain that the number entered by a user is a positive number less than 10, so 1 through to 9. This second example calculates the number of bits needed to represent a certain value. And the feature of this loop is that we're using a function inside the while there. So we're using the power function to calculate whether 2 raised to a certain exponent is less than the number. So we can find the exponent, what we need to raise that 2 to the power of, to be able to store that value.
Yeah, and this final example that we've got here is a simple game loop. And basically, it just keeps repeating until it detects that the user has closed the window.
Yeah, cool. Okay, and that's it for looping. So looping instructions allow us to easily repeat code. And the great thing is we can specify how many times to repeat it. So it could be 0 to many with a while loop, or we could use the post-testing loops to run 1 to many times.
Next up, we've got input validation, as well as passing variables and custom data types, records and enumerations.
Okay, we hope you've enjoyed watching these videos, and we look forward to seeing you soon.
This has been a Swinburne production. Swinburne University of Technology.
Hi, and welcome to Swinburne Codecasts. I'm Andrew Kane.
And I'm Cliff, and in this video we'll be looking at the case statement.
So far, our programs have been able to execute a sequence of instructions, and if we wanted to make a decision, we could use an if statement to choose between two paths based on a condition.
Well, that's good, but I've got a menu in my current program that matches a user's option to many paths. Is there a better way than using many ifs?
Well, this is an example where we can use the case statement. And the case statement is like the if statement, but it lets us match one value to many paths. So we take the value and pick a matching path. I think that will work for your menu program.
So here we have my little soundboard program with my if statements. So as you can see, it gets quite complicated, and this is only 4 options currently.
Okay, so this is where we can use our case statement. So notice that each of the if statements is comparing the same value, or the same variable, the option variable, with different values. With the case statement, we can write it like this, and you'll see straight away it's like much shorter. And the case says, based on the value of this variable, search for the matching branch. So if option is 1, then we play the guitar. If option is 2, we play the piano, etc.
Okay, that's great. And I think that would make it really easy if I wanted to add in more instruments as well, instead of having those big else blocks.
Yes.
But
yeah.
With this example, what happens when somebody, say, enters 5 as the option?
Well, at the moment, it won't do anything. So the option, because there is no matching branch, when the option is 5, it would just jump straight to the end.
Oh, okay. So it just wouldn't do anything.
Yes. Or
Okay.
it would. It would look and see that there's nothing to do.
Okay.
It would then do nothing.
Okay, well, I think we should probably have something there that catches the user options if it's not in the case.
Okay, so you want to do something if it's not, in this case, 1, 2, 3, or 4. If there's anything else like 27 or minus 156.
Yeah.
All right, so in that case, what you can do is include an additional branch inside the case statement that catches all of the other options. So if it's not 1, 2, 3, or 4, then it does this other branch.
Okay, I think that's great.
Excellent. Cliff, do you want to explain quickly how that works?
Yeah, sure, Andrew. So here's the code that we've got here. It enters at the main procedure. And the first thing that we do is we allocate space for the option variable.
Yep, and that's going to store an integer.
That's right. That's right. So the program begins, and I print out a menu for the user to read that explains what the program does.
Yep.
Then what we do is we use the read integer function to assign a value to that option variable.
Yeah, so this read integer function will display the prompt to the user and validate what they entered is actually a number. So it's going to return us back a number. What number do we want the user to use this time?
In this case, let's go with 3.
3, cool. So 3 is then stored into the option variable.
That's right. So then we get to the case statement, and what it does is it reads the value of option.
Yep,
And
so
then-
it's going to get 3.
That's right, yeah,
So
yeah.
it's actually using the number 3 here.
That's right, yeah,
Cool.
yeah. Well,
Yeah.
it's not a case of beer.
Yeah.
It's a case of option.
Yep. That's bad, Cliff. Anyway, all right. So case option is actually just the value 3.
That's
so
right.
case 3.
So it's going to match that to the number 3, which in this case will play the sound effect bass. Then it's going to skip over the rest and get to, well, I've added this little line at the end just to output to show when the program's finished.
Yeah, so we can then press enter to continue.
Yeah, that's right.
All right, so that one would have played the bass sound effect because the user had entered the value 3. So let's try it again. If we run it again, we'll choose a different option this time.
Yeah. So once again, it starts at
Yep.
main. We create the space for option.
Yep.
Prints out the soundboard menu here, but the user this time is going to enter like 1, 2, 3.
Yeah, so the number 123.
Yeah.
And 123 will be stored in option.
Yep, that's right. And then once again, the case statement will read that value 1, 2, 3.
Yep.
And
So it gets that from the option variable.
Yep. It's not one of the predefined
It's
parts.
not 1, 2, 3, or 4.
or 4. So it'll write out you have not made a valid selection, and then
Yep.
the program's going to end once again with the sound is finished.
Yeah, press the key. That's
Press
okay.
enter.
Cool. All right. Okay, so here are some additional examples. This first one is similar to our other program. It's printing out a menu, and we're using the case statement in this instance to print out or to execute multiple lines in each case. So that is possible as well. It doesn't have to be just one line of code. You can have multiple lines in each branch.
It's pretty cool. And here we've got a function that's a rainbow color picker. And what that does is it uses the random function to create a number that will be the choice for the case.
Yeah. So this is demonstrating that you don't have to just use a variable for the case statement. You can calculate that value in any way. So here we're calling a function, and the result of that function determines the value that we're looking up in the case statement.
And so
you could have long, complicated expressions there if you wanted to.
And so that will return the color as well.
Oh yeah, so in this case, the actual function itself returns the color that we picked based on the value from that random number function.
Cool.
And our last example here is one that draws different shapes based upon the option that the user has selected. So we're able to use the case statement to say, in the case where we're wanting to draw, if this shape is a triangle, for example, then we draw this option. If it's a rectangle, we draw this option.
Yeah, I use something similar to that in some of the games that I've made, actually, to draw different enemies and things like that.
Yeah, so you could use the case in this way for a number of different programs like that. Okay, that's the end for case statements. Case statements are very similar to if statements. They allow us to branch in our code. In this instance, the case statement works by evaluating an expression, so it gets a value and matches that value to one of a number of different paths, and it then executes that path. It is a bit more limited, but it can be very useful for certain situations.
So what's up next?
All right, so some other videos. If you haven't already seen our if video, that's probably a good one to look at. Otherwise,
You should probably check out the looping videos as well.
Yep, that'd be useful.
Yeah, I reckon would have been great with my soundboard, actually, because then we could play more than one sound.
Yeah, that'd be excellent. All right, thank you very much, and hope to see you again next time.
This has been a Swinburne production. Swinburne University of Technology.
And welcome to Swinburne Codecasts. I'm Andrew Kane.
And I'm Jake, and in this video, we'll be looking at creating our own modules.
So far, we've been writing all of our program's code in a single file.
And that's been really cool so far, but wouldn't it be great if we were able to split our code into multiple files so that we could not rewrite it every time we needed to use it?
Yeah, and we can use modules to do that. So modules are going to allow us to sort of separate our code into different files. Then each file can have sort of a different purpose. And so if you wanted to, if you had a bunch of code that you were reusing over and over again, you could put that all in a single file and then just use that file across your different projects.
Yeah, so I don't need to rewrite my code every time I need to use it. I could just say, use this code that I've written in this file. I wrote it once and I can use it every time.
Yeah, that's right. And I mean, the cool thing with that is you don't have to say copy and paste the code in. If you then find a mistake, you can fix it in that one file.
Fix it once,
and it'll
fix
sort
it
of
everywhere.
compile your other programs and they'll all be fixed.
Yeah, perfect.
Yeah, cool. So is there any code that you have been reusing or that we've been reusing so far?
Yeah, so read string and read integer, those functions that we've been using to read from the terminal, I've used those in a lot of programs.
Yeah, so they've all been programmed into a separate module. And we can actually have a look at how that module works. Now, modules, when we create them, have two parts. The first part defines the interface of the module. And this is a list, basically it's just a list of all of the functions, procedures, variables if we had them, which we wouldn't, of course, because they'd be global. The functions and procedures that we want to make available to others. So they all go in the interface. We don't say how they work here, we just say what they are.
So it's kind of like, this is what I can do, and I'll be able to do everything that I've listed here.
Yeah, so it's like advertising.
Yeah.
This is
this is what I do.
This is what I have to sell. roll up, use my read string.
Yeah, it's the best on the block.
Yeah, that's right. So in our terminal user input unit, we've got read string.
Yeah, read integer, read double.
Yeah, etc. Yeah, so that is the list of functions in this case that are available from this unit. If you use this unit, that's what you've got access to.
And it also defines any parameters it needs and what it will return.
Yeah, so these are all functions. So what parameters go in, what values come back.
If it was a procedure, obviously it wouldn't return anything.
Yeah, you just say it takes these parameters.
Yeah.
Yeah.
If
so
any.
That's correct, if any. Now, the second part, once you've defined the interface, you then need to provide that implementation. No hollow salesman here. You can't say I've got a read string.
To follow up now.
Yeah. You got, if you've said you're going to have read string somewhere, you actually have to implement it.
Yeah.
And so that goes in the implementation section. And these are just like, if you look at this is just like the code you would have had previously inside the program.
Yeah, there's just no difference.
Yeah, absolutely. The only thing that matters is that each of the things you said you were going to have exist in here.
Yeah, it has to be the exact same name so that it knows.
And the exact same parameters, same types, everything.
Same function and procedure, basically.
Yeah. But here we define the instructions, the steps that those functions and procedures perform.
Yeah.
You can also have other functions and procedures that you don't advertise. So you could have local ones that you use, but other people shouldn't use.
Yeah, exactly.
If you had some sort of intermediate steps.
Yeah,
that
something
people don't
only
need.
useful to this module.
Yeah, that's right. Yeah, and then they would go inside here.
Yeah.
So then what we can do, if we pop back to another program, we can see here, this is an example of how we use that module that we've created. So here we're able to import the module, and that gives us access to all of the functions and procedures inside that. And then you've got to make sure when you compile it, it's compiling both.
Yeah.
Some languages will do that automatically for you. Others, you'll have to provide the implementation for both.
We need to say compile this, this.
Yeah,
and so on.
yeah. Either the compiler works it out for you, or you have to do it yourself.
Yeah.
All right, that's it for modules. Modules are super simple. I mean, it is really just a case of copying and pasting your code into different files and saying what you're going to provide.
But they're really powerful because it means we don't have to repeat code. And if we find, as you said, if we find fixes, we fix it once, we fix it everywhere.
Yeah. So now you can, if you want to do, if you've got a bunch of functions or procedures that you think, wow, these could be really useful across a lot of different projects.
Or I'm using this so much, I should make this a module.
Yeah, you can chuck it in a module, reuse it everywhere else.
Yeah. So next up, we think we should have a look at our records and enums videos.
Yeah, so they're ways of organizing data. Another one would be to have a look at file I/O, because that would then be a way of saving that data into file as well.
Yeah.
All right, hope you've enjoyed this video, and we look forward to seeing you again soon.
Bye.
This has been a Swinburne production. Swinburne University of Technology.
Hi, and welcome to Swinburne Codecasts. I'm Andrew Kane.
And I'm Jake. And in this video, we'll be looking at basic file I/O.
So far, our programs have had data within the program existing inside our variables, which we can use. We can read and write values to those variables. But when, of course, the program ends, those variables go away. It's all the data's gone.
And that's been really, really cool so far. But if only there was a way that we were able to save and load our data in between our programs running.
Yeah. We can use file I/O to read and write values from files. And this is what all programs do if they want to keep data between executions.
So before we jump into how to actually do that, why don't we just take a quick look at how we've been doing it so far, basically, in our programs.
Yeah, so reading and writing to files is pretty much the same as reading and writing to the terminal. So the way we read and write to the terminal and the way we read and write from files is only very small change between the two.
That's really good.
So let's have a look at the way we can read from file to start with. Read from the terminal to start with.
Read from the terminal, yeah.
So what we can do, this instruction here allows us to read a line worth of text from the terminal. And what it does is it effectively scans from, you can imagine the terminal input as being the cursor.
Yeah.
When you start typing, that text is sort of flowing into the program, and it has its own position of where it's up to, and it then moves its cursor through the text that's coming in. So it's scanning or reading the data that's coming in. And we can read in, say, a whole line worth of data. So we're looking for the end of line character. So it reads everything up to that end of line and puts that all into one string value. And that's how we could read in a string's worth of data.
And that end of line character is actually our enter key.
Yeah, that's right. Yeah. So when you hit enter, that tells it where the end of that line is.
So it's scanning for that enter key, and now it has some string that it's storing into a variable.
Yeah, so it's read an entire line into a variable.
So, we don't always read in strings. We want to read in integers sometimes.
So if we know for certain that it's going to be an integer, then the way we can do that is using this code here. What it will do is this one will actually read in 3 numbers. So off the one line, it's going to scan through the line and it's going to look for an integer. It will then read the next integer and then it will read a double. And in between that, you can have some white space. So it might be tabs or spaces or even new line characters, but it will look for those 3 numbers.
So that it's got some way to distinguish between the 3 values that it's trying to read in.
Different programming languages might work slightly differently here. So in one case, the program might crash if it's not a number. So this is why you have to be certain it is a number. In other cases, it will just say, well, it wasn't a number, and it will sort of give up. And so you've got to be a little bit careful with how that works, but the basic idea is the same. We can read in multiple values.
And we can read in a combination of the both. We can read in some integers and we can also read in a line.
Yeah, so you could read in, say you had a number of integers at the start of the line and then some text that followed it. You could read in the 2 integers and then the text. It is harder to say read in some text and then some numbers on the same line because you don't have really a very clear way of identifying where the end of the line is and the start of the text.
Because you could have numbers in your string.
That's right.
And it does...
so then you've got to get into some processing. You probably then want to read the whole line in and work out for yourself where the numbers were. So if we're working with files where we can determine the format of the data in the file, you want to keep it as simple as you can. So like have everything either on its own line or have, this line is going to have these 2 integer values and then this other double value or something
This
like
is
that.
how I'm going to separate each of my values.
Yeah, so that you can then work it out when you break it back up.
And it's pretty the same for writing. So we can write out some strings.
Yep.
We can write out a combination, again, of a string and an integer. And we don't really have the same problem as before because...
You can do this in any way you want.
The
Writing
program
out
knows,
is easier.
And also, some of you might have noticed that when you wrote out a double, it was writing out, say, 10 decimal points worth of values.
In scientific notation as well.
Which is kind of useless sometimes when we're just writing our programs.
Yeah, we want it to be a simple, easy to read number. You can actually format that output quite easily so that each of the languages provides a different way of just specifying, I want it to be at least this wide and I want it to have at most 2 decimal places.
And so we can indicate that like this.
Yeah. All right, so that's the basics of the things you can do with file I/O. You need to be able to write or read the data in and write the data out.
Yep.
The next bit we need to be able to do is actually hook that up with a file.
Yeah.
Yep.
So instead of reading from the terminal, we're reading from a file, but we have to tell the program which file we're reading from.
Yeah, that's right.
And we can do this. It's just a variable. We've got the file.
Yep.
And we give it a name, and we can assign the name of our file to to this actual file variable.
File variables. Yeah. So the file variable in your program represents which file it is you're going to be interacting with off your disk.
Yeah.
Yeah.
So once we've done that, in some languages we have to mark the file as that.
Read or write, depending on how you're going to work with it. And then we can read data from it. So here's an example of how to read a value from the file. Now I'll notice all we're really doing, the main difference here is instead of saying read this data, which would read it from the terminal, we say read this data from this file and then store it in these variables.
Yeah, so it's reading almost the same. Instead of reading from the terminal, read from the file and put it here. What you read on this line, put it into this variable.
Yeah, so these are using pass by reference. And so we're getting effectively passing across a pointer, in this case to the name variable, and what we're reading is then being stored into that name variable.
Yeah, and so read line will read a single line from the file, and if we want to read the next line, all we do is we just put this instruction in again, and it will read the next line.
Yeah, so that instruction just reads one line. If you want to read another line, just have one followed by another.
So it's just iterating through the lines in the file.
Yeah, that's right. And so what we could do, if you wanted to read all of the lines in a file, there is a special EOF, which is the end of file. So we can check, we could loop while we're not at the end of the file, read another line in, and in this case, just print the line out. So this is going to read a text file and print out the text file.
It's going to read every single line in the file, store it in our variable, and write out that string.
Yeah. So it'll store each one at a time. So it'll read the first line into that variable. When you print it out, it will then read the next line and it will store it over the top of that old value.
Yeah, and it's the same to write to a file.
Yeah, that's right. So to write to a file, what we would do is if we have some values we want to write to the file, such as we've got here.
Yep.
Then we can just get those variables. Once we've opened the file, we tell it that we're going to write to it. We can then write each of those values into the file. And when we're finished, we close the file and we're done. So reading and writing for files is actually fairly simple.
Yeah, it's pretty much the same as reading and writing to a terminal.
Yeah, the main thing you've got to think about is how you're going to organize the data so that when you've stored it, you can get it back to reuse it
Because
again.
the program needs to know what it's about to read in
That's
from
right.
the file.
Yeah.
Just like it needs to know what it's going to read in from the terminal.
Yes. Yeah, exactly. All right, so that's it for basic file I/O. So we've seen an example of how to read values. Here's an example for how to write values as well. So we've got both, just reading and writing values.
And these files will persist, and then we can read it in again next time we run the program. It's not just going to disappear from memory like how it has.
Yeah, how our variables do.
Yep. So next up, why don't you guys take a look at our records and enums files?
There's also arrays is probably the topic after that. Arrays and pointers are also good to have a look at. Otherwise, we hope you've enjoyed this video, and we look forward to seeing you again soon.
Bye.
This has been a Swindon production. Swinburne University of Technology.
Hi and welcome to Swinburne Codecasts. I'm Andrew Kane.
And I'm Jake, and in this video we'll be looking at structuring data using records.
So far, we've been using built-in data types to determine the kinds of information that we can store in the variables in our programs. And so we can store things like numbers and text.
And that's been really great so far. But now that I'm starting to write larger programs, I want to be able to deal with more meaningful things in my code. So, for example, I'm writing this program about student data, but I've got lots of variables all over the place, and I just like a way to be able to deal with the different pieces of data related to one of my students.
Well, that sounds like a case where we can use records. Records allow us to create a composite data type where we define the structure of that type in terms of a number of different fields. So each record is a structure that contains multiple values inside it. Multiple fields is the way I would think about it.
Yeah, so this is the code I was just talking about earlier. And so I'm trying to make this program deal with student data. So I've got things like the name, their age, their ID, their course, even their GPA. But if I want to add more data, it's just getting messy. If I want to pass it to functions, I have to pass everything. So can I use a record here to be able to group this data?
Yeah, so this is a case where we could use a record in order to, as you said, put all of those things together into a student. Now, also, if we look at this at the moment, the variables you've got are things like strings, integers, and doubles. There's nothing really meaningful in terms of your student program here. Yeah. So if we add a type to that, what we can do is we can create our own record type. And this defines the structure of those multiple fields.
Cool. So I'm storing all the data I was before, but I'm grouping it into this student record.
Yeah. So the student record is composed of multiple fields. And the structure of those says that, the first thing that we're going to have inside each of these student records, we have a name, which is a string. We have the age, which is an integer. We have a number, which is a string. Course is a string, and GPA is a double. And when we come down to main now, instead of having each of those variables or multiple different variables for each of those different pieces of information, what we can actually have is one student variable. And that student variable is composed, so is made up of all of those different pieces within the one variable.
So the data's living inside of the student variable now.
Yeah.
So how can I access my data? It used to be a variable, like a string that I could interact with, but now it's in a student.
Yeah, so our a student variable is a student. And what we can use is the dot operator allows us to access the fields of that student. So here what we can do, instead of, we still want to access the strings and integers inside the student, but we can say a student dot name. And so that would be the name value inside that student variable. And if we do a student dot number, then that is the number value, the number variable or number field inside that student variable.
So once I access that field, it's like I've got my data back.
Yeah, well, all the data still lives inside that one record.
Cool.
So when you type a student, that is a student. And the way I would think about it, then when you push dot, you've got the option of what you want to access there. So you can access either the name, the age, the number, the course, or the GPA. If you do dot name, then you've got a string. You can do anything with that string you could have done before. So a student dot name is a string.
Yeah.
Yeah, just like name was a string.
Cool.
Yeah. So we can read and write to those values. So you can use those inside the assignment statement. So we can say a student.name is assigned the result of read string. And we can also read the value in the case where we print out the name. So the name comes from a student.name.
So that they behave like every other variable that we used to use.
Yeah.
So here I'm writing out all of my variables within my student. Is there a way that I can put those into procedure? Do I have to pass all of my variables like I was previously?
Okay, so what we could do now is create, so it's a good idea, creating a procedure to print out the student But what we can do now, which I think is quite cool, is that instead of having to pass across like the name separately from the age to the number to the course to the and
Yep,
the GPA,
yep.
you know, hundreds of different parameters here. What we can do instead is pass across the one new data type that we've created.
Yep.
So we can pass across the student record, and that passes across all of the data associated with that one student, and that would be copied into that variable.
So I've got all my data that was in a student within my print procedure, and I can access it with toPrint.
Yeah, so up here, so when we call, down here in main, when we call print student, we pass across a student. And all of the data in a student will be copied into the toPrint student parameter when that procedure call executes. And so when you access it in here, you've got a copy, and we can read toPrint.name, and you get the name that is inside that variable. toPrint.number, you read the student number, age, etc.
So you mentioned that we're copying the student to the print student procedure, but wouldn't that be a slow way of doing it? Is there a quicker way that we can, why do we have to make a whole copy of it?
Okay, so in programming, there's two different ways we can pass parameters. There's one called pass by value, and then there's another called pass by reference. And what we do with pass by value is you get a copy of the data. So here, when we call print student, a copy of a student is sent into toPrint. And so to do that, it does copy everything. It knows the structure of that record. So it knows that it contains inside it a string, an integer, two more strings, and a double. It copies that big chunk of data. That is actually quite a big chunk of data. And it copies that into the toPrint. So you get a duplication of all of that data. Now, some languages support pass by reference. And others you can do it manually with a pointer. But pass by reference allows you to say that what you want to pass across is not a copy, but the ability to refer to the other variables. So the easiest way to think about it is a pointer. You know, this is a value which points to, you know, the actual student you want is over there. And so toPrint would refer to our a student variable, and it can do that very quickly. So the reference is a pointer that refers to the original.
So I haven't had to spend time making a whole copy of my data. I'm just dealing with the data that I had.
Yeah, that's right. And when we pass it by reference, there are other things you could do. So if you modified it, depending on how you passed it by reference, if you modified it, you could also be changing the original.
Cool.
But in this case, we just want to print it out. So we can, we get the reference, we get it much quicker, and then we can access the individual fields just as if it is a copy. I mean, it doesn't really matter, it's just a bit faster.
Cool. So I've moved my writing to a procedure.
Yep.
Can I move my reading?
Yeah, so we could also create a read student function in this case. And in this instance, we could print out, or we could return, a student. So student, when we've created our own type here, the student type can be used anywhere you could use any other types. So wherever you could have used an integer or a string, etc. before, we can now use our student type. So before we could create functions that return numbers, for example.
Yep.
We can now create functions that return students.
That's awesome.
And the compiler knows what the student is because we've defined what the structure of that student is.
Right, cool.
With the type declaration.
Cool.
Yeah. And so inside our read student function, we could store values into the name, the number, the age, the course, and the GPA for that student. And then at the end, when we return it, it returns all of that student data. Because it knows what it is, that big chunk of data.
So the code looks really similar. It just means that I don't have to pass all my variables as separate parameters.
Yeah, and in this case, we can return all of them in one. You
Perfect.
couldn't have created a function before that returned
Exactly.
5 different
Yeah,
variables.
'cause I can only
a function
return
returns one value.
Perfect.
Yeah, so
This
this
is
we can
perfect.
return one value which just happens to contain 5 values.
Yeah.
Yeah. Okay, so another cool thing that we can do with records is, if we come back to main here, I've declared another student variable, very creatively named another student. And what we can do, notice how when we assign here, we've got a student is assigned the result of calling the read student function.
Yep.
That data, that's going to call that function. When that function returns, it returns back that whole student. We copy all of that data into to a student.
student record.
Now, we can actually do that ourselves. We don't have to just use functions to do that. We can do that between variables ourselves. So if I create another student variable here, I can say another student is assigned a student.
So exactly like an integer or a string, we can
Yeah.
assign our own data types.
Yeah, that's right. So assignment works as long as the things are the same type on both sides.
Yeah, so because they're both a student, I
Yeah.
can just assign it what the current student is to another student.
Yeah, so the A student data here, all of the data, so the name, student number, age, course, GPA, all of that data will be copied into another student, and we'll now have 2 copies of that data in memory.
Cool.
And so when we print out a student and we print out another student, it'll be exactly the same.
But what if I don't want it to be exactly the same? So I want to change another student's name.
All right, so if we change another student's name, when we print them out, what we should see now is the first student has the original data,
Yep.
and the other student has a copy, but the name has changed because they are 2 separate variables. Each has its own distinct set of values.
Yeah, so they're 2 separate
Students.
student
Yeah.
sets of data. That's awesome.
Yeah, they're 2 students. It says
So I could
a student is a student, another student is a student.
Cool.
Yeah.
So I could change anything in my separate student.
Yeah, that's right. Yeah.
Yeah. Cool. Okay.
Okay, Jake, do you want to explain how this works?
Yeah, sure. So the program starts at main and we create 2 student variables, one named a student and one
Yep.
named another student. And they contain the student structure that we declared in our type.
Yep. So that means that each of these variables has inside it a field to store the name, field to store the age, number, course, and GPA.
So the first instruction is calling read student, and read student returns to us a student, and we take that student and assign it to a student.
Yeah.
So we have to jump to the read student function,
That's okay.
and we have our result variable of type student because we're returning a student.
Yep. So we print out the prompt.
Yep. And then we as we can see here, we call read string,
Yep.
which returns to us a string, which we now assign to the name field of our result variable.
So what are we going to have as the
So let's say Fred again.
Fred.
Gotta
Okay.
be Fred.
So Fred is stored into the result.name
Yeah.
variable.
Then we jump down to the second line and we call read string again, and we're getting Fred's number, and Fred's number 1. So we assign number 1 to our number field of our result variable.
Yep.
And again, we go to the next line and we're getting an integer this time because we're getting Fred's age, and say we get 21. We assign 21 to Fred's result age field.
Yeah. So the age field of the result variable.
Yeah, and then
And we can do the same thing for the course name, and that's stored into the course, and the same thing for the GPA, which
we're
is
getting
stored
a
into
double.
the GPA.
yeah.
Yeah.
So now
So
we,
then at the end of this function, all of that data in result is returned back to the calling code.
yeah.
And so what happens is that is then assigned, that sort of when read student finishes, all of that data comes back and is stored into the a student variable.
Cool. Then we proceed to our second instruction, and we are getting that a student variable that we've created and getting the data in it and assigning it to our another student variable.
Yeah, so this is going to mean that Fred is copied across to the name, the number 1 is copied across to the student number, 21 is copied across to the age, and we get the course and the GPA
We have
getting
an exact
copied across.
copy of
Yeah.
Fred stored in our another student variable.
Yeah.
So the next instruction in this piece of code is to assign the string another student to the name of another student. So there can only be one Fred.
Yeah. Okay. All right. And so when we execute print student, we pass across a student,
Yep. So we're calling print student, which is passing
a reference.
a reference to a student.
Yeah. So toPrint is now going to refer, as we can see here, toPrint refers to a student.
student.
So when we print out the name, so toPrint.name is actually Fred.
Yeah.
And
print out.
toPrint.number is
So
Number 1.
whatever's stored in a student at the time that this runs will be printed out.
because that's what we passed
because we're just,
across.
But yeah.
Yeah.
Cool.
And then when that finishes, we come back to main. When it prints out another student, toPrint now points to that other,
Exactly.
the other variable. And so we can see when it prints out the name in this case, we get another student because that was the value we copied
Exactly.
in there.
But the rest of the data is going to be whatever was in another student, which will be, number 1, age of 21, etc.
etc. Yeah. All right, cool. So here are a couple of other examples. We have player, for example, and so this could store like the player's location.
Yeah, its bitmap,
Score.
its name,
Yeah.
stuff like
Yeah.
that. Everything we need to have our player.
Yeah, in this computer game.
Yep. Second up, we've got our account example. So we could have things like the name of the account holder, the total funds remaining, everything that
Credit limit.
everything that we need to know about the account.
Yeah. And the last one is a component from a, say, a circuit diagram. And we've got the type of component and its position in the diagram. So that's all we have for records. Records allow you to declare your own data type which contains multiple fields, and you declare the structure of those fields. What do you want contained inside this record or this structure? Coming up next, our other videos, we've got another one on enumerations, which is another kind of data type.
Yep. You could also have a look at pointers. So that's what we were talking about in this program about pass by reference. We could use pointers.
Yeah, so we've got a video on pointers and how pointers work. And if you're on to ready for the next big topic, that's arrays, which I think's very cool.
Very cool.
Yeah. All right, thank you very much, and we hope you've enjoyed this. Bye.
This has been a
What do
Swindle
we usually say?
That's good. That's good. Yeah.
That'll do.
No, that's it. It's like, that's the classic sign.